What makes a perfect game? Detailed handcrafted visuals, fantasy environments, and a wide variety of animated characters? Or is it more about the game mechanics, physics for interactions, and AI to make the creatures feel alive? What is the special ingredient in game development recipe? In this class, we will dive deep into the secrets of JavaScript, web animation, and front-end web development. Let's try to discover what makes a great game and how we can build it from start to finish using just our own JavaScript code with no frameworks and no libraries. This class is for beginners, but some basic knowledge of front-end web development is required to get the maximum value. Let's go! I'm giving away a ton of free game art with this class. I hope you like it. We will control the blue bull. Its job is to protect hatching eggs from waves of hungry enemies. Player can position all the game objects by pushing them around. We can push the eggs and hatchlings to safety, or we can push the enemies out of the way. While building this project, I will show you how to use HTML, CSS, and plain vanilla JavaScript to implement many important web animation and game development techniques. We will apply physics to make game objects interact with each other. We will learn how to restart our game by pressing a button, how to control FPS of the whole game, how to trigger periodic events. We will apply mouse controls, learn how to manage and animate 8 directional sprite sheets. We will trigger and animate particles when a certain event happens, and much more. Let's take it step by step to make sure we really understand the code, and by the end of this class you will have all the skills you need to build your own games and animation projects. I create an IMG element with an ID of overlay. The source will be overlay.png. You can download all project art assets in the resources section below. There are individual images and sprites as I'm using them in this class, as well as a bonus folder with source files where each game object comes split into high-resolution pieces you can edit and animate. So if you want, you can mix and match, combine them with art I gave you for other classes where we are using this mushroom forest theme, and you can create your own unique game environments. All the art in this class is copyright free. Feel free to download them, modify them, and reuse them in your own projects in any way you want. I'm already giving you all art you will need to follow this course, but for those of you who want to take it further, if you have a graphics editor like Photoshop, you can, for example, color shift the images to create even more visual variety. Character source files can also be rigged and animated in 2D sprite tools like Dragon Bones or Spine. Check out the source files and use them however you want. It's my gift to you as a thank you for spending your time with me. So we have a basic setup in index.html and style CSS. Canvas defaults to this small size of 300 x 150 pixels. If I set its size with CSS, I would be setting only its element size, and that would stretch my drawings. HTML Canvas has actually 2 sizes, element size and drawing surface size, that can be set independently. I want both sizes to be the same to prevent any distortions, so I will size my canvas with the JavaScript here. I wrap everything inside load event listener because we will use a lot of art assets and I want to make sure all my images are fully loaded and available before any JavaScript code runs. First, we need to point JavaScript towards our canvas element using getElementById. We save that reference in this custom variable I call, for example, canvas. Then I take that variable and from it I call built-in getContext method, passing it 2D as context type argument. This will initialize a built-in object that holds all canvas properties and drawing methods. We can now call them from this ctx variable. So as I said before, I want to set canvas size, both element size and drawing surface size to the same value. We can do it like this. Canvas.width is 1280 pixels and canvas height is 720 pixels. Now the full background artwork I prepared for you is revealed. Perfect. I want to write this game as object-oriented codebase to make it more modular. We will have a class for player and another class for game to manage all the game logic, the main brain of this codebase. We will also need animation loop to draw and update our game over and over to create an illusion of movement. Game class constructor will expect a reference to canvas element as an argument like this. Inside, we convert it into a class property, and we will need width property, and the value will be this.canvas from line 15 .width, like this. This will give us 1280 pixels as we set it up on line 4. We do the same thing for this.height. We are taking a reference to canvas element, and we are setting the width and height of our game to be the same as the width and height of canvas. We will finish this setup by connecting this canvas argument to this canvas variable a little bit later when we create an instance of our game class using the new keyword. We will get there soon, I'll show you. Before we do that, I also need the player to have access to width and height properties of our game, because the player needs to know, for example, when it moves outside the game area and so on. I will give it access to the entire game class and all its properties and methods by passing it a reference to this game class as an argument, like this. Inside, we convert it to a class property. Keep in mind that I'm not creating a copy of game object when I create player. Objects in JavaScript are so-called reference data types, so this.game here on line 9 doesn't create a copy. It just points to a space in the memory where our main game object is stored. All the code inside a class constructor gets triggered when we create an instance of a class using the new keyword. We will do that in a minute. I want our codebase to automatically create player when we create an instance of our main game object, so I can do this. Inside the class constructor, I create a property called this.player, and I set it to new player, like this. I can see that player class constructor on line 8 expects game as an argument, so I pass it this keyword, since here we are inside that game class. This keyword here refers to the entire game object. Here on line 18 we are creating an instance of player class, and we are saving it as this.player property on the game class. Structuring our code like this will automatically create player when we create game. We create an instance of game object like this. Custom variable I call, for example, game, and I set it equal to new game. On line 14 I can see that the game class constructor expects canvas as an argument, so I pass it canvas variable from line 2. This variable will get converted to a class property, and the width and height of the game area will be extracted from it as we planned. Let's check if everything worked by console logging this game variable. Nice, I can see the correct width and height properties, and we have an instance of player class in there as well. This is one of the ways how you can organize and connect your objects in an object-oriented JavaScript codebase. Keep in mind that the order in which we define the classes matters. JavaScript file is read line by line from top to bottom. JavaScript classes are hoisted, but they are not initialized until that particular line is read. So player class needs to be defined before it's used. A very good idea would be to split our JavaScript into individual modules and import and export our classes between files as needed. For this project, I will write all the code in a single JavaScript file to keep it as beginner-friendly as possible. Using JavaScript modules would require us to run this code through a local server. It wouldn't run the code by simply opening index.html file in a web browser anymore. If you are more experienced, it will be very easy for you to finish the project with me, and then if you want, you can split individual classes into separate modules yourself. This class is for beginners, so let's focus on object-oriented principles and animation techniques. A function that sits on an object is called a method. Player will need a draw method to draw and animate it. It will expect context as an argument to specify which canvas we want to draw on. We will connect this context argument to our ctx variable from line 3 when we call this draw method a little bit later. I will show you. I want to draw a simple circle at first, representing our player. To draw a circle on canvas, we take context and we call begin path to tell JavaScript we want to start drawing a new shape, and we want to close previous shape if there are any. Then we call built-in arc method, which expects at least 5 arguments. It expects x and y coordinates of the center point of the circle, its radius, start angle in radians measured from the positive x-axis, and end angle where the arc ends, again in radians measured from the positive x-axis. There is an optional 6th argument for counterclockwise. If we don't define it, it will default to false, which means that the arc will be drawn clockwise. So start angle is 0 radians and end angle is math.pi times 2. It's a full circle. Now we can choose to call fill to fill the shape with color, or stroke just to outline the shape. Or we could use both. We will do that soon. How do we actually draw the player on canvas now? On the game class, I create a method I call, for example, render. This method will draw and update all objects in our game. It expects context as an argument. Inside, I take this.player from line 23, and through this reference we access the draw method on player class we just defined from line 11. This method contains the code to draw a circle representing the player. I can see it expects context as an argument, so I pass it along. This context we passed to the render method. Now I can take this game variable that holds an instance of the entire game class, and from there I call render. And I pass it ctx from line 3. That ctx will be assigned a variable name context here, and it will be passed along to draw method on player class. Nice, we are drawing a black circle representing the player. It's here. Maybe you can't see it, so let's give it different x and y coordinates to move it. Instead of hard-coding all these values, I want to create properties on the player class and then use those here. We will need x and y coordinates for player position, but because in this class we are learning about positioning hitboxes and character images that can have very different shapes and sizes, I will have to create property for x and y position of player hitbox, and I will need to have a different x and y property for player sprite sheet image. It will make more sense as we build it. I want to be very explicit with my variable names to make it absolutely clear which value is the position of the collision box and which value is the position of a sprite sheet. So instead naming these properties just x and y, I will name them collision x and collision y. X and y position of the collision hitbox, of the center point of the collision circle. All objects in our game today will have circular hitboxes because I want to show you how to make them push and slide along each other. I want the starting position of the player to be exactly in the middle of the game area, so collision x will be this.game from line 9, and from that property I will extract width from line 23. And in the middle, so times 0.5. Collision y will be the same, this.game.height times 0.5. Now I can use these values as x and y arguments passed to canvas arc method, like this. Now we can move the player around by changing values of collision x and collision y properties. We will also need a property called collision radius, which will define the size of this circular player hitbox. I use it here inside the arc method as well. Default fill color is always black. I can override it here by setting canvas fill style property to white, like this. Instead of filling the shape with color, we could also just stroke it. Again, by default, line width of stroke is 1 pixel and the color is black. I set line width to 3 pixels and I set stroke style to white. Notice I'm defining these canvas properties outside of any class or method. I do that on purpose because this code will only run once on the initial page load. You can't always do that if you have multiple objects with different fill styles and stroke colors. In that case, you would have to define these properties inside the draw method and switch between them over and over. The problem with that is that the draw method will be called 60 times per second, and changing canvas state like this could get performance expensive. It's a good idea to structure code in a way where you change canvas state as little as possible. And when I say canvas state, I mean anything from transforms to changing colors of fill style and stroke style. That's why I put this code here instead of placing it directly inside the draw method, to make it run as little as possible while still applying the colors and settings as I need them. I can also call fill here. So now we are filling and stroking the same path defined by arc method. I want the fill to be white, but I want it to be slightly transparent. Canvas has a global alpha property to set opacity of the shapes we are drawing. The problem is that when I set global alpha to a different value, everything drawn after that will be semi-transparent. I want the transparency to only apply to the fill color of player collision circle. To limit certain canvas settings only to specific draw calls, we can wrap that drawing code between save and restore built-in canvas methods. Then, if I set global alpha to 0.5, it will affect only that specific drawing action. In our case, it will only affect the fill of this circle. So, save method creates a snapshot of the current canvas state, including its fill style, line width, opacity, as well as transformations and scaling, if we are doing that. Then I can do any changes to that canvas state I want. In this case, I just set opacity to 0.5. This fill call will be affected by that changed opacity, and then we call restore, restoring all canvas settings to what they were when we first called its associated save method. For that reason, this stroke will not be affected by reduced opacity. Save and restore methods allow us to apply specific drawing settings only to selected shapes without affecting the rest of our canvas drawings. I want to move the player around using mouse. We already know that the code inside game class constructor will be executed at the point where we create an instance of this class using the new keyword. We are taking advantage of that by automatically creating an instance of player class here. We can actually run any JavaScript code in here. I can even put event listeners here to make sure they are automatically applied when I create an instance of game class. I create an event listener for mouse down event. When mouse button is clicked, the code inside this callback function will run. I test it by just console logging the word mouse down. If I save changes, because I'm already instantiating this class on line 46, this event listener is automatically applied. Now when I click on canvas, console log is triggering. Nice. Callback function on event listener auto-generates an event object that contains all kind of information about the event that just happened. To get access to that object, we just need to give it a variable name. You can name it whatever you want, but the convention is usually event or E. Let's console log this event. I click on canvas and I see it here. I inspect it. You can see it contains a lot of information about that mouse click. For example, we see X and Y coordinates of that click here. There are many other properties that tell us which mouse button was pressed and many other things. I want to take the coordinates of the click and save them as properties on the main game object, and from there we will be able to access them from our player object as well. I create a new property on game class called this.mouse. It will be an object with X property with default value of this.width times 0.5, and Y will be this.height times 0.5, so the middle of canvas horizontally and vertically. We will also want to monitor when the mouse button is pressed down. Initially, it will be set to false. If I console log e.x and e.y, you can see we are getting X and Y coordinates as we click around canvas. The problem is that the coordinates are from the top left edges of the browser window. I would like to measure the click coordinates from the top left corner of canvas instead. So when we click here, in the top left corner of canvas, we get X and Y 0, 0. For that, we can use a different property on this auto-generated event object called offsetX, which will give us horizontal coordinate of the click on the target node. In our case, the target node, the target of the click, is canvas element. Now you can see the values get very close to 0 as I click close to the edge of canvas. I could also add the event listener just to the canvas element itself rather than the entire browser window object. If I click closer to the top left corner, we are getting values close to 0, 0. Perfect. Probably it would make sense if I use this.canvas property here from line 31 instead, since we are inside a class and we have the reference to canvas available here. So now we are getting coordinates of the click measured in pixel distance from the top left corner of canvas. Even when we resize the browser window, this is working well. I want to save these click coordinates inside our custom mouse property so that they are available to other objects in our codebase, such as the player. Inside the mouse down event listener, I take that this.mouse.x property from line 36 and I set it equal to e.offsetx. This.mouse.y will be e.offsetY. I create another console log and I will log these newly updated mouse properties. When I click on Canvas, we get an error that says cannot set properties on undefined. Set in X on line 43. It's telling me that I can't set X property on something that is undefined. For some reason, this.mouse is undefined when accessed from inside event listener. It is because when this callback function on event listener runs, it forgot it was originally defined inside this game class constructor. It forgets what this keyword stands for. This is expected. To make the event listener remember where it was first defined, where it sits in the lexical scope of our codebase, we can simply use ES6 arrow function here instead. One of the special features of ES6 arrow functions is that they automatically inherit the reference to this keyword from the parent scope. Arrow functions remember where in the codebase they were originally declared lexically, and they adjust their this keyword to point to the correct object, to the parent object. Now, this.mouse.x and this.mouse.y are correctly updating to the new values, making the current mouse coordinates available all over our codebase whenever they might be needed later. I delete the console logs. When mouse down event happens, I set pressed from line 38 to true. I copy this event listener. This one will be for mouse up event. When the mouse button is released, everything here will stay the same and we set pressed to false. I also create an event listener for mouse move event. Let's console log it to check. Yeah, that's working. Let's make the player move. I create a custom method I call update. Inside, I set collision X from line 14 to the current mouse X position. And collision Y will be the current mouse Y position, like this. To run this code, we actually need to call the update method. I will call it from inside render down here. I delete this console log. If we want to see any movement, we need to be calling render over and over, so let's put it inside the animation loop here. I call built-in request animation frame method, which sits on the browser window object, but we can also call it directly like this if we want. I pass it animate, the name of its parent function, to create an endless animation loop. Now I need to call animate to actually start the animation. When I move mouse over canvas, we get trails. I only want to see the current animation frame, so between every loop I use built-in clear rectangle method to clear the old paint. I want to clear the entire canvas area from coordinates 0, 0 to canvas width, canvas height. Now the player sticks the mouse as we move it around canvas. Perfect. I want to create a line between mouse and the player to clearly show the direction in which the player will move. Inside the draw method on player class, we start a new shape by calling begin path. Move to method will define starting X and Y coordinates of the line. In this case, I want the line to start from the coordinates of the player object. Line to method will set the ending X and Y coordinates of the line. In this case, it would be X and Y coordinates of the mouse. Then we call stroke to actually draw the line. This works, but since the player is always able to catch up with mouse cursor so fast, we can barely see the line. Let's give player speed. Speed X, horizontal speed, initially I set it to 0. Speed Y, vertical speed, also initially set to 0. Inside update method we will calculate speed X. First I set it to hard-coded 1 pixel per animation frame and I increase player X position by horizontal speed. That worked. I also do it for vertical position. There are two ways we can make player follow the mouse. One way would be to simply take the difference between the current mouse position and the player position on horizontal x-axis and set that difference as horizontal speed. And we also do that for vertical movement. Now, the player position is correcting for the difference by the entire amount of that distance, so it makes the movement instant. What if I make it move only by the 1/20th of the difference between player and mouse position per animation frame, horizontally and also vertically? I create class properties for dx, distance between mouse and player horizontally, and dy, vertical distance. I replace those values here. It's easier to read this way. I don't want the player to follow all the time as we move mouse over canvas. I want only when we click somewhere or when we hold mouse button down and move around. Inside mouse move event listener, I say only update X and Y mouse position if mouse is pressed. Now I can click around to make the player move to that location, or I can drag that point around while holding mouse down. Perfect. The problem with this technique is that the speed is not constant. Player moves very fast at first because 1/20th of the distance is at first a big chunk when they are far apart, but as they get closer, 1/20th of that distance becomes smaller and smaller amount of pixels to be traveled per animation frame. You might want this particular motion for your project, but for the game we are building today, I want the player to move at a constant speed. We will have to use the second technique for that. Inside update method, I calculated the distance. We already have dx, the distance between mouse and the player horizontally. We also have dy, the distance between mouse and the player vertically. We want to calculate the distance between these 2 points. We can do that by calculating hypotenuse, the longest side of this imaginary right triangle. We can use Pythagoras theorem formula, or in JavaScript we have this built-in math.hypotenuse method. This method will calculate the length of the longest side for us if we pass it 2 other sides of the triangle as arguments. Keep in mind it expects dy first and dx second, which might be a bit unexpected if you never saw this before. Horizontal speed is the ratio between dx, horizontal distance between mouse and the player, and the actual distance. Same with speed y. It will be the ratio between the distance on vertical y-axis and the actual distance between the 2 points. As a backup, when some of these values are undefined at first, we say or 0, like this. We are dividing horizontal and vertical distance, these sides, by the actual distance represented by the longest side of a right triangle. dx and dy is always a smaller number than the distance because the distance is a hypotenuse, the longest side. For that reason, the values we get as speed x and speed y will be somewhere between 0 and 1. That will give us the correct direction of movement at a constant speed. There is much more to be said about this technique, but for now, this is all we need to know. I'll get back to this. Now, the player is moving at a constant speed towards the mouse. I can have a speed modifier. I set it to 5, for example. I use it down here, and I multiply speed x and speed y by that modifier. After we add this speed modifier, the player circle will actually never stay still anymore. It will be swinging back and forth, in this case by 50 pixels, because the speed modifier pushes it too far in both directions. I can fix it by saying only move the player when the distance between mouse and the player is more than speed modifier. Else, set speed x to 0 and speed y to 0 as well. This works perfect. So we covered one simple and one more advanced technique to make the player move towards the mouse. Now it's time to add solid, randomized, non-overlapping obstacles. I create a class I call obstacle. Constructor will expect game as an argument, and inside I convert that reference to a class property. Same as before, it will be pointing towards the main game object, and we need it here because through this reference we have access to game width and height, mouse positions, and some other properties we will be adding later. We will have access to all these values from inside obstacle class through this.game reference from line 54. As I explained before, all the objects in our game will have a circular collision hitbox and a separate rectangular sprite sheet. For that reason, I will be calling these properties with very descriptive names to make sure it's very clear what's happening when we are moving and animating everything later. Collision X, the center point of collision circle of each obstacle, will be a random value between 0 and the width of the game. That width is coming from line 62 here, and we are accessing it through this.game reference we created on line 54. We will also need collision Y, vertical center point of collision area circle. It will be a random value between 0 and game height, this value. Collision radius will be 60. We will also need a draw method that expects context as an argument. I want that circle that represents hitbox area of each obstacle to look the same as the circle representing the player, so I take the drawing code from up here. Just for the circle, so this code block. I copy it and I paste it down here. This code will work here because, the same as with the player, we gave our obstacles properties called collision X, collision Y, and collision radius. We will also need the same naming on all these properties between different object types in case we want to have a reusable collision detection function. I will show you how to use that one later. It's simple. Anyway, here we have a code to draw a circle with a radius of 60 pixels with 50% opacity white fill and white fully visible full opacity stroke. This obstacle class here is a blueprint. We will use it to create individual obstacle objects. The actual logic to create and manage these objects will be down here inside the main game class, which is the main brain of our code base. I create a property called this.obstacles. It will be an array that holds all currently active obstacle objects. It will start as an empty array at first. The number of obstacles will be, for example, 5. I create a custom method on our game class I call, for example, init, initialize. Its job for now will be to create 5 randomized obstacle objects and put them inside obstacles array we just defined. Inside, I create a for loop. It will run 5 times because we set number of obstacles to 5 up on line 76. Each time it runs, it will take this.obstacles array from line 77 and on it will call built-in array push method. The push method adds one or more elements to the end of an array and it returns the new length of the array. I will pass it new obstacle like this. The new keyword will look for a class with the name obstacle and it will trigger its class constructor. Up on line 53 I can see that obstacle class constructor expects game as an argument. Down here, init method sits inside that game class, so I pass it this keyword, which here represents the entire game object with all its properties and associated methods, making all of these available from inside obstacle class. Now I console log game and I can see obstacles array is completely empty. To fill it, all I have to do is call init method we just wrote, like this. Now I can see the array contains 5 obstacle objects. I double check to make sure all properties have values. If you see undefined in any of these, it means there is a problem in your code base. All is good here. Same as I'm drawing and updating the player from inside game render method here, I would like to draw all 5 obstacle objects on canvas. I take obstacles array from line 77. We already know that it contains 5 objects and that each of these objects was created using our custom obstacle class from line 52. So they all have access to this draw method we defined on line 59. So here inside render, I take that obstacles array and I call built-in array for each method. The for each method executes a provided function once for each array element. First, we need to define a variable name, which will be used within this for each method to refer to individual objects in that array. I will call each object obstacle. So for each obstacle object in obstacles array, I call their associated draw method from line 59. On line 59, I can see that it expects a reference to context as an argument to specify which canvas element we want to draw on. I simply pass along this context that was passed to the parent render method. Nice, we are drawing one player and 1, 2, 3, 4, 5 randomly positioned obstacles. I go up here and I make the obstacles a bit larger. Every time I refresh browser window, they get positioned randomly somewhere within the canvas area because that's how we define their position on lines 55 and 56. What if I want to make sure that the obstacles never overlap, like this, and maybe to take it even further, since these will be solid obstacles that player can't move through and has to walk around them, I would also like there to be a minimum spacing between them and also between the edges of the game area, just to make sure all the creatures that will soon be crawling here don't get stuck and can eventually find their way automatically around each obstacle. It's actually easier to implement all of that than you might think, but we have to take it step by step and explain a couple of tricks we can use here to achieve that. Inside init method, we are simply adding 5 randomly positioned obstacles right now. I have to delete this. We will need to structure this code a bit differently here. So first, I want to make sure the obstacles don't touch, that they don't overlap like this. We could also adjust the number of obstacles to be the maximum number of circles possible that can fit into a certain area without any two of them overlapping. Sometimes we call this circle packing. So let's write a very simple circle packing algorithm here. I will use the basic technique where you just try to place circles at random positions many times, and only those that don't collide with already existing circles will actually be turned into obstacle objects and drawn. This is also called a brute force algorithm. It's not very smart, it just tries over and over many times. I will create a let variable called attempts. It will be my safety measure. We will count how many times we tried to draw a circle, and we will give up after a certain number of attempts. The assumption being that there must have already been enough opportunities to place the obstacles. I will use a while loop. You have to be careful with this one. If you create an infinite while loop, you will slow down your browser and you will need to restart it. Very old computers might even freeze if you use while loop wrong. New browsers can usually deal with it. My goal here is to randomly place circles over and over, and before we actually turn that circle into obstacle object, we check if it overlaps with existing circles. Only if it doesn't overlap, we add it into the obstacles array. I want this while loop to run as long as obstacles array length is less than number of obstacles, less than 5. We defined that array here, and number of obstacles was defined here. As a backup, I also set a secondary condition. Only continue running this while loop as long as attempts is less than 500. This is important because if I set radius of an obstacle to be a very large number, or I set number of obstacles to be so large that they can't physically fit into the available area, we would get an endless while loop. But with this secondary condition, JavaScript will just try 500 times, and if by that time they couldn't find placement for all the obstacles, it will give up. I think 500 attempts is more than enough. Every time the loop runs, we have to increase attempts by 1 for our safety backup plan to work. Every time this while loop runs, we create a temporary object I call, for example, test obstacle. It will be equal to the new obstacle and I pass it game, this keyword, as an argument as we did before. Let's console log this test obstacle. Nice, we have 500 test obstacles in console now. You can see they have collision X, collision Y, and collision radius properties as they should. My goal now is to take this temporary test obstacle object and compare it against every other obstacle in obstacles array. Of course, at first, this array is empty, so the first obstacle should always be placed without issues. The second test obstacle will compare itself with the first one, that's already in the array, and so on. So for each obstacle in obstacles array, I will run a circle collision detection formula. Circle collision detection in JavaScript is quite simple. We basically need to calculate the distance between the two center points of those two circles. Then we compare the distance between two center points with the sum of their radii. If the distance is less than radius of circle 1 plus radius of circle 2, they overlap. If it's exactly the same, the circles are touching. If the distance is more than the sum of radii, there is no collision. We already did this when measuring the distance between player and mouse. This time, the 2 points we want to measure the distance in between is the center point of obstacle circle 1 and center point of obstacle circle 2. So again, we are creating this imaginary right triangle where dx is the difference between 2 points horizontally, dy is the difference between the 2 points vertically, and the actual distance is the hypotenuse of that triangle. So here we use Pythagoras theorem formula or a built-in math.hypotenuse method, passing it dy first and dx second. So now we know what is the distance between the two center points. Sum of radii is radius of circle 1, in this case radius of test obstacle. And the second one is the radius of whatever obstacle object inside obstacles array we are currently cycling over. As we said, if the distance is less than sum of radii, how will I do this? Outside the for each method, I create a flag, a let variable I call overlap, and initially I set it to false. If the distance is less than sum of radii, we set overlap to true because collision was detected. Outside the for each method, if overlap is still false after we created test obstacle and after we compared it using collision detection formula with every other existing obstacle in the array, if it doesn't collide with any of them and overlap variable is still false after all these checks, only then we take obstacles array and we will push this test obstacle that passed our checks into the array. Now, when I refresh the game, 5 obstacles will be randomly positioned and they will not be overlapping because those that do overlap are discarded and only non-overlapping circles are used. Because I have my safety measure here on line 108 and we always stop this while loop when we reach 500 attempts, I can actually go up here and I can set the number of obstacles to a large number that I know will never fit. Our code will just place as many obstacles as possible and then it will stop trying. We know this is working because if I keep refreshing my project over and over, we never see overlapping circles. I mean, no obstacles overlap with each other. Player can overlap at this point with obstacles. We don't care about that right now. I set the number of obstacles to 10. Now let me show you how we will be attaching images to these circular collision hitboxes and how to position the image in relation to the hitbox so that it makes visual sense and creates an illusion that this is not flat canvas but a 3-dimensional environment where the player can actually walk around these obstacles. You can download all project art assets in the resources section below. In index.html, I create another image element with an ID of obstacles and source will be obstacles.png. That image is a sprite sheet. We will randomly cut out one of these frames for each obstacle object. I don't really want to draw the actual image element, so I hide it with CSS. Inside obstacle class constructor, I create a new property I call this.image. I point it towards that obstacle sprite sheet using getElementById, like this. Let's set the number of obstacles to 1 for now. Inside draw method on obstacle class, I call built-in canvas drawImage method. This method needs at least 3 arguments. The image we want to draw, so this.image from line 58, and x and y coordinates where to draw it. I will draw it at this.collisionx and this.collisionY at first. Doing this will simply draw the entire image sprite sheet, and the top left corner of this sprite sheet will be starting from the center point of obstacle circle, because this is how by default images and circles are drawn on HTML Canvas. If I refresh the project, our new obstacle is positioned randomly somewhere on canvas. I created this sprite sheet for you so I know that individual frames are 250 pixels wide. I save that value as sprite width variable. Sprite height will also be 250 pixels. If you are using a different sprite sheet, you can get the width by dividing the width of the entire sprite sheet by the number of columns, and the height is height of the sprite sheet divided by the number of rows. In case we want to add scaling later, I will also create independent width and height properties. For now, they will be equal to sprite width and sprite height because I sized the sprite frames to the exactly same size as I want them to be drawn in the game. Draw image can also accept optional fourth and fifth arguments defining the width and height. The entire image will be squeezed or stretched to the area we define by these values. It will look like this. What I actually want to do is to crop out one of these 12 obstacles and draw only that one at the size of 250 times 250 pixels. For that, I need to use the longest version of draw image method that expects 9 arguments. Those 9 arguments are the image we want to draw, source X, source Y, source width, and source height of the area we want to crop out from the source image, and destination X, destination Y, destination width, and destination height to define where on destination canvas I want to place that cropped out piece of image onto. So if I pass it 0 as source X and 0 as source height, and sprite width, sprite height like this as source width and source height. I need to spell width correctly. So now we are drawing the top left frame in our sprite sheet. As I said before, I will set separate X and Y position for the sprite sheet. There are multiple different ways to do this. I can just simply position the image directly on top of collision X, which is the center point of collision circle, minus the width of the image times 0.5. This will center the image horizontally, exactly over the collision circle. To actually apply this, I need to use sprite X as destination X property passed to draw image method here. Be careful when passing arguments to draw image method. The order in which you pass these arguments is very important. Okay, if I refresh the page, I can see it's been correctly centered horizontally. I do the same thing for sprite Y, and I use it as destination Y property passed to draw image method. Now the sprite sheet is directly on top of the collision circle. I set collision radius to a small value. I want this small collision area to be positioned at the base of the plant where the stone is, because that will be the solid area that's touching the ground that our game characters will have to walk around. Since our sprites are set size of 250 times 250 pixels, I can actually use a hard-coded value here. Plus 40 will move it up. Minus 40, minus 50, minus 60, minus 70. Yes, this seems alright. I set the number of obstacles to 10. What if I want to make sure that not only the obstacles don't overlap, but also that there is an additional minimum 100 pixels space in between, so that they are more evenly spaced out around the available game area, as well as allowing enough space in between the obstacles, so the game characters can easily walk around them. I create a helper variable. I call, for example, distance buffer, and I set it to 100 pixels like this. Then I include a distance buffer here in sum of radii to apply this buffer in between obstacles when we are placing them. Nice. To make sure this is working, I increase distance buffer to 150 pixels. That should make it even more apparent. Yeah, so this is how we can easily control obstacle spacing. I also want to make sure that obstacle sprite images are entirely drawn within the game area and not partially hidden behind the edges. I could have done this inside obstacle class constructor when defining these values initially, or I can also just do it here, since we are not drawing that many obstacles and their positions are calculated only once on the first page load anyway. I make sure the left edge of obstacle sprite sheet is more than 0, so it's not hidden behind the left edge of canvas. At the same time, I make sure that the right edge is not hidden. So sprite x must be less than the width of the game area minus the width of the obstacle. Nice. When I refresh the page, I can see horizontally obstacles are always fully visible. For vertical position, I won't check the image, but the center point of collision circle. More than 0 vertically will not be enough. I want to define an area that is reserved for this background artwork. I don't want ground obstacles to appear over this area. I create a property called top margin. I guess this top area is around 260 pixels of height. Let's check here. Yes, 260 looks alright, because I want to make sure the base of the obstacles doesn't overlap with this top area, but I don't mind if the top of the obstacle sprite sheets overlaps like this, because this looks like the obstacle plant is standing in front of the background forest view, so this is fine. I will also check if the center point of obstacle collision area circle is less than the height of the game area. I want some margins. I can, for example, create a helper variable that's equal to collision radius of the test obstacle times 2. I replace this hard-coded value with this.topMargin property we defined, plus I want to give it some additional top margin so that characters and especially enemies can squeeze in between obstacles and game boundaries when walking across the game field horizontally from right to left. I will also account for the margin from the bottom of the game area to create some space there. We wrote code that automatically places obstacles in our game world. These obstacles never overlap, and their collision areas are placed to allow enough space in between them. This will make the next steps much easier because we need enemies and friendly NPCs to be able to automatically walk around them using very simple artificial intelligence. We have different images for obstacles, but right now we are drawing only the first top left frame at coordinates 0, 0. We can crop out different areas from the obstacle sprite sheet. Horizontal crop area will start from the position we pass as source x argument to draw image method here. 0 times sprite width is this frame. 1 times sprite width will be this frame. 2 is this one. 3 is this one. Back to 0. To select from which row we are cropping, we use source y argument here. Again, we multiply row number by the actual height of individual sprite frames, so 0 times sprite height is this, 1 times sprite height is this. Now we are on row 2 and there is no row 3 because we start from row 0. Images are drawn and cropped from the top. So instead of hard-coding these values that are currently set to 0, 0, let's turn them into class properties for clarity and easy control. This.frameX will determine which column we are on in our obstacle sprite sheet. If I do a random number between 0 and 4, this will not work. There is no column 1.74, for example. We need integers, numbers without decimal points, so I wrap it in math.floor to round the random value generated by math.random to the closest lower integer. This code will give me either 0 or 1 or 2 or 3, so one of our sprite columns. When we multiply these integers by the width of a single sprite frame, and we pass that value as a source x argument to draw image method, we are defining horizontal cropping coordinate. That worked. Perfect. I will do the same for frame y, which will determine sprite row. We have only 3 rows. This line of code will give me integers, either 0 or 1 or 2, corresponding to the number of rows we have available in our obstacle sprite sheet. Now we can replace this hard-coded 0 with this.framey, so source y argument passed to draw image method will be this.framey times this.spriteheight. I will do that in a second. Random values in frame x and frame y combined will give us random image out of these 12 available obstacles. Each obstacle object will have random frame from this sprite sheet assigned to it. I will finish this a bit later. On the main game object, I create a method I call checkCollision. I want this to be a reusable utility method that takes object A and object B, and it will compare them and check if they are colliding or not. We will be able to use this all over the code base. wherever collision detection between two circles is needed. The way I'm building my game, all characters and objects will have a circular collision area, which will be a solid base that nothing can walk through, and everything will react and walk around everything. Using this, we can also push things around. I will show you. To check collision between two circles, we have circle A and circle B here. We need to check dx first, the distance between the center point of circle A and the center point of circle B on horizontal x-axis. This reusable method will work only if all objects involved have properties with same naming conventions, so we will make sure we name x and y positions on each object as collision x and collision y. I'm using these overly descriptive property names so that it's very clear when x and y coordinates relate to collision area circle and when they relate to image sprite sheet positions. This is a tutorial, so I want things to be very clear and easy to understand. We will also need dy, the difference between the center point of circle A and the center point of circle B on the vertical y-axis. Then we want to know the distance between these two center points, so hypotenuse, the longest side of this imaginary right triangle. Right angle, 90 degrees, is here, and this is the distance. Pythagoras theorem formula, or alternatively built-in math.hypotenuse method, and we pass it dy first and dx as the second argument. To determine whether or not there is a collision, we compare distance between these two center points with radius of circle A plus radius of circle B. I will save this value as a custom variable I call, for example, sum of radii. So if distance is less than sum of radii, we know the circles collide. If the distance is the same as sum of radii, circles are touching. If the distance is more than sum of radii, we know there is no collision. This function will simply return true if there is collision and false if there is no collision. Let's use our custom check collision function. Up here, inside update method on player class, we check for collision between player and obstacles. We have one player object and multiple obstacle objects, so to compare all, we will call for each on obstacles array, which holds all currently active obstacle objects. I will call each object in the array with a helper variable name, obstacle, and I will console log check collision method we just defined. We know it expects circular object A and circular object B as arguments to compare the distance of their center points to the sum of their radii, so I pass it this, which means this player object, as circle 1, and obstacle we are currently cycling over with this for each method as circle B. Keep in mind that this reusable check collision method can only compare objects that have collision X, collision Y, and collision radius properties defined in their class constructor. So I will make sure I keep the same naming conventions for all objects in the game we are building today. As the player moves, we are getting false and true in the console. Seems like this is working. Let's actually only console log the word collision when collision between player and obstacle is happening. Now it's even easier to see that our code is working. Perfect. Inside render method, I will draw obstacles first, so behind, and player after it, so it will be drawn on top. What if I want to also resolve our collisions? What I mean is, if player collides with an obstacle, I don't want it to be able to walk through it like this. I want the player circle to be pushed 1 pixel back away from the obstacle circle, in a direction that points directly away from the center point of the obstacle. This simple thing will make the obstacles solid, and the player will actually slide around the obstacles, and it will create nice physics. Let me show you. I'm already calculating everything I need for that inside our custom check collision method, but this function currently returns only true or false. I need this reusable method to return more values so that we can use them inside player class to calculate collision resolution vector. Functions and methods in JavaScript can return one value like this, but they can also return an array that contains multiple values. I want to return true or false, collision status as the first element in the array. element with an index of 0. We also want to return the distance we are calculating on line 127. We will also need sum of radii from line 128. And we will need dx and dy from lines 125 and 126. So now our custom check collision method not only checks if collision is happening or not, it also gives us other values from calculations that happened along the way. It's important that we remember the order in which we are returning these values. Element with an index of 0 is collision status, true or false. Element with an index of 1 is distance, sum of radii is index 2, dx is index 3, and dy is index 4. I will just copy that array that gets returned here and I comment it out, just so I can see it as a helper reference. Now I want to take each of these values and save them as separate variables so that we can use them to calculate collision resolution here and push the player in the correct direction away from the obstacle it's currently colliding with. I will use something called destructuring assignment. Let's just write it and I will explain it when we see the whole thing. I say let variable is this array. And it is equal to check collision between this player object and the obstacle that for each method is currently cycling over. I have to replace this first expression with a variable name I want to call it. I want to call it collision. It will be that true or false value depending on the distance between circle center points. So if this is true, there is collision. If this is false, there is no collision. Destructuring assignment syntax is a JavaScript expression that makes it possible to unpack values from arrays or properties from objects into distinct variables. I'm basically saying here, create 5 variables for me. The first variable, called collision, is the array returned when we call check collision method between this player and obstacle, index 0. Distance variable is that array, index 1, and so on. Destructuring assignment does this automatically behind the scenes. It creates these 5 variables and pairs them with the values that sit at these indexes in the array, returned by check collision method. This might be a bit strange if you never saw it before. JavaScript destructuring is a good thing to get familiar with. Modern frameworks use it a lot. I'm basically just taking the array returned by check collision method and I'm assigning each value to its separate variable name so that I can use them here. So here we are inside update method on player class. We are cycling through obstacles array, comparing player with each obstacle object. If there is collision between player and obstacle, if collision variable is true, we console log AAA. This works. I want to create a vector, kind of a small line between 0 and 1 pixels in length. That line will point in the direction in which we want the player to be pushed to resolve the circle collision, to make sure that colliding player and obstacle repel each other, causing the player to slide along the radius of the obstacle rather than going directly through it. Horizontal vector will be the ratio between dx, distance between player and obstacle center point, on the horizontal x-axis, and the actual distance between these 2 points we calculated before using check collision method. Because dx will always be less than distance, because distance is hypotenuse, it's always the longest side of the imaginary right triangle. Unit x will always be a value between 0 and 1, because we are dividing small value by a large value. Unit y will be the ratio between dy, the distance between center points on the vertical y-axis, and the actual distance between the 2 center points. Again, it will be a value somewhere between 0 and 1. These could also be negative values depending on how our objects sit in relation to each other on horizontal and vertical axes. So actually, unit x and unit y will be a value between -1 and +1. If I console log unit x and unit y, we can see these values. The combination of these 2 values being added to player's horizontal and vertical position for each animation frame will make it move in a certain direction and certain speed away from the center point of the obstacle. I do that by taking player collision x position, the center point of player's collision circle, To push it outside the radius of the obstacle it is colliding with, I move it horizontally to the position of center point of obstacle circle plus the sum of radii of player circle and the obstacle circle plus one additional pixel outside times that unit x ratio to give it the right direction away from the obstacle's center point. We do the same thing vertically. Center point of player collision circle will be moved to the position of collision center of obstacle circle plus sum of radii of obstacle and player circle plus 1 pixel times unit y to give it the right direction of the push. I am trying to explain this in a very beginner-friendly way, but don't worry if it's still a bit unclear. This is an important technique, and every time you use it, you will feel more and more familiar with this code. Eventually, it will click for you how it works. All you have to understand here is that this code is pushing the player 1 pixel outside the collision radius of the obstacle in the direction away from the center point. And this is how you create very simple but very effective physics simulation in your game. Try to move the player around. This feels very good, doesn't it? Suddenly, our obstacle circles turned into solid, impassable objects. Well done if you followed all the way here. This is the main trick we are using today for our physics game. I adjust speed modifier to a small value. We learned how to make the player move towards a mouse or towards a specified point in a 2D space, and how to make it navigate its way automatically around solid obstacles. This is a powerful technique and you can do with it more than you can imagine. We will explore some of that today. Hope you're having fun! I prepared a special 8-directional player sprite sheet for this class. You can download it in the resource section below. I will include some alternative colors probably. Mine is blue to match the mushrooms in my game art. I will hide it with CSS here. Inside player class constructor, I create a reference to that image using getElementById and I save it as this.image property. Inside our custom draw method, I take context and I call built-in Canvas draw image method that we already used before. We already said that the drawImage method needs at least 3 arguments, the image we want to draw and x and y where to draw it. This will just draw the entire sprite sheet. We can pass it width and height to squeeze the entire sprite sheet into that specified area. We actually don't have these properties defined. Sprite width, the width of a single frame, will be 255 pixels. Sprite height is 255 as well. Then we create separate width and height properties to allow the potential if we want to introduce it later. Now we are squeezing the entire sprite sheet into the area of one sprite frame. You probably already know that we will need the longest version of drawImage method, where we add source x, source y, source width and source height. These values will first crop out a portion of the image, in our case, a single sprite frame. After that, we draw that frame at the position defined by the last 4 arguments. To draw the top left frame at coordinate 0, 0 is simple. We just did it with obstacle sprite sheet. Source x, source y, 0, 0 to define the beginning of cropping rectangle, and sprite width and sprite height as source width and source height arguments to define its size. Now we see only one frame. I will calculate position of sprite sheet image in relation to collision x and collision y coordinates of player hitbox in these 2 separate properties, just for clarity. So keep in mind, these properties define the center point of player collision circle. These 2 properties will define the top left corner of sprite sheet frame image we are currently drawing to represent the player. On canvas, circle coordinates are from the center point, rectangle and image coordinates are from its top left corner, and image and rectangle goes towards right bottom, depending on its width and height from there. We have to consider these when writing the following code. Sprite x will be positioned in relation to collision area. It will be collision x, the center point of collision circle, minus half of the width of player frame, like this. I need to use sprite x inside the drawImage method as destination x argument here. And for this to work, we need to recalculate this value every time collision x updates. So I need to put this inside the update method here. And I also do it for sprite y, which will be collision y minus the half of player height. I can delete it here. And I use sprite y property here as destination y argument past the drawImage method. Now it's positioned on top. I actually want this collision circle to match the little shadow on the ground below the player as closely as possible, because that's the contact point we will use when interacting with other objects in our game. Since the player is fixed pixel size, I can offset it by a hard-coded value. If we were scaling our characters in this game, I would use a relative value here. -100 moved the player image up, so this is alright for now. Same as we did with obstacles sprite sheet, I want to navigate within our sprite sheet by swapping from frame to frame. Horizontal navigation is handled by multiplying sprite width by an integer representing the column in the sprite sheet, passed as source x argument here. When we cycle through this, we will animate individual directions, individual animation loops. To swap between directions in the sprite sheet, the way our specific sprite sheet is organized today, we have to multiply sprite height by an integer representing sprite row. You can see row 0 is player facing upwards, away from us. Row 1 is top right, 2 is the player facing right, 3 is bottom right, 4 is facing down towards the camera. Row 5 in our sprite sheet is the player facing bottom left, 6 is facing left. I think you get the idea. I put these integers into class properties. Frame X for horizontal sprite navigation, frame Y for vertical. I replace these hard-coded values with my new variables, and now I can change what frame we are currently cropping out from the player sprite sheet by giving different values to frame X and frame Y. I want to change frame Y, the row we are currently animating from the sprite sheet, which will determine where the player is facing. I want that to depend on the current angle between mouse and the player, on the position where they are currently in relation to each other. For this, we have a built-in method called math.atan2. Math.atan2 returns an angle in radians between the positive x-axis and a line projected from 0, 0 towards a specific point. We will use it to calculate the angle between the player and mouse cursor, and based on that angle we will select which row in the sprite sheet we want to animate so that the player is always facing in the direction it is moving, towards the mouse cursor. We will need dx and dy, so I move them up here. So these values calculate the distance between the player and mouse cursor horizontally and vertically. Keep in mind that it makes a difference if you use mouse first or the player first in this calculation. I already wrote this code here before without thinking we would use it for this, so we might have to adjust to it a bit. I will show you exactly what I mean. Math.atan2 expects dy first and dx as the second argument. I will console log angle we are calculating, and I can see it is changing, and the values are from -3.14 minus pi to plus 3.14 plus pi. This checks out because we know that full circle is 2 pi. Approximately 6.28 radians, which converts to 360 degrees. I will repeat that math.atan2 returns an angle in radians between the positive x-axis and a line projected from 0, 0 towards a specific point. Because I'm using mouse first and the player position second when calculating dx and dy, I'm getting values from math.atan2, where the current mouse position represents point 0, 0, and player position is the point we are projecting a line towards. For the purposes of a nice visual, it would work much better if player was the static 0, 0 center point, but I will leave it as is. And from the values I'm getting in the console, I will create this graph with breakpoints in radians. It was actually easy to make because I just needed one value as an anchor, and I knew the whole area is from minus 3.14 to plus 3.14, and we have 8 player directions, so each slice was 6.28 divided by 8. Anyway, you don't necessarily have to understand all of this right now. When we have the full code, you can play with the values, which will hopefully bring more clarity. It took me a while of using math.atan2 before I fully understood, so if this is your first time seeing it, don't put too much pressure on yourself. If I pause the screen, this is the point 0, 0, this is the line projected towards another point, and math.atan2 gives us an angle in radians between this positive x-axis and this line. So by using this console log to get an anchor point so that I can see which angle values we are getting, I constructed this helper visual, which I will now use to correctly swap player rows in our sprite sheet to make the player always face the mouse. If angle is less than minus 1.17, set frame Y to 0. I will copy this a few times. Minus 0.39 is frame Y1, plus 0.39 is frame Y2, 1.17 radians is frame Y3, 1.96 is frame Y4. Let's see. So far this is working great. I think we got it. I can delete the console log. 2.74 is frame 5. This area is a bit weird as the circle ends and starts. I have to say if angle is less than minus 2.74 or if angle is more than plus 274, I want to use frame Y6. If angle is less than minus 1.96, frame Y is 7. Pay attention to brackets here, minus and plus values and less than operators. If you are getting any unexpected behavior, make sure all of this code is the same as mine. It's easy to make a small mistake here and break your code accidentally. For this to work, for all directions, I have to adjust it a bit. I can, for example, take these lines and put them here, because with else-if statement, it matters which one is checked first sometimes. I reduce the player speed modifier to 3 so we can clearly see how it turns while testing. Now we can turn the player in all 8 directions. Perfect. We will learn more about sprite animation later in the class. For now, I'm happy with this. Since this is a physics game where we are placing collision areas at the base of each object, we want to be able to quickly swap between the view where these collision areas are visible and invisible. It will help us to tweak the physics and gameplay elements as we are developing them, while giving us an easy way to check how the changes we just made will be visible for the player, who will not see these hitboxes. I want to create a debug mode. By pressing letter D on the keyboard, we will toggle all helper collision elements on and off. On the main game class, I create a property called this.debug, and initially I set it to true. Down here, where we placed our event listeners, I create another one. We will listen for key down event. Let's just console log event object. When I select canvas by clicking on it and then I press any keyboard key, we get this auto-generated keyboard event object. Inside we have a property called key. You can see I pressed letter R, so the key that was pressed sits inside e.key property. I say if e.key is a D, set debug property from line 123 to its opposite value. So if it's currently true, set it to false. If it's false, set it to true. This way, pressing the same key, letter D, will toggle debug mode on and off. I tested by console login this.debug. I press D over and over, and in console I see it switches between true and false. Perfect. I remove the console log. Up here inside the draw method on obstacle class, I say if this.game.debug is true, only then draw the collision area circle. Now I can press letter D to show and hide them. That works well. I want to do the same for the player. If this.game.debug is true, only then draw the collision circle and also the line between the player and the mouse in this case. Positioning and size of the hitboxes is not perfect yet, but we do have all the logic in place now. Great job. I can make collision radius of each obstacle smaller to better match the part where it touches the ground. We have different obstacle types here. The mushroom and this big carnivorous plant should probably have different collision circles, which can easily be done, but for now I'm happy with this. You can see that the collision formula we wrote before is all we need to give the player very simple path-finding ability. It will just walk around obstacles automatically, and since we placed obstacles in a way that there are always spaces in between, it's unlikely that the player will get stuck. I can also see I'm only getting the first 4 obstacle images, which reminds me to go here to line 108 and include randomized frame y value as source y argument in obstacle draw image method. Now I'm randomly getting one of all 12 obstacle images. You can play with this and position and size your hitboxes differently if you want. I'm happy with what we did so far. I want to make sure the player can't walk so high that it's above this background artwork area. Let's create some horizontal boundaries first. If the center point of player collision circle is less than x coordinate 0 plus collision radius, set it to 0 plus collision radius. So when the left edge of the circle is touching the left edge of canvas area, don't allow it to go any further left. I want to do the same thing for the right edge. Of course, we can delete this 0 plus here and here. If the center point of player collision circle is more than the width of the game minus the radius of player collision circle, make sure it can't go any further right. Nice. Vertical boundaries. If collision y is less than vertical coordinate 0 plus top margin we defined to be 260 pixels from the top plus collision radius, make sure that the player can't go any more up. That works, nice. Yes, this is what I wanted. Again, we can delete 0 plus here and here. Bottom boundary. That's simple. If collision y is more than the height of the game minus collision radius, make sure it stops there, like this. That works. If I make player collision radius smaller than obstacle radius, because of the margin we defined while positioning obstacles, there will always be a place for a player to squeeze between obstacles and the edges of game area. There is not, so down here I increase that margin. This should do it. You can compare your code with in-progress source code I will include to download in the project section below in multiple points during this class as we progress with our project. I can see the bottom of the sprite sheet is being cut off on the lower rows. It's because the height of a single frame is actually 256 pixels. Now it's fixed. In Visual Studio Code Editor, I select View, Word Wrap to make the code break to another line if it cannot fit, if it's too long. I want to set FPS for the entire game because with my previous projects, a lot of you mentioned that games run too fast on your game in high refresh rate screens. Request animation frame method we are using here will automatically adjust itself to screen refresh rate, so for normal screens that would be around 60 frames per second. But on some of the new gaming screens that people use, that speed would be double. Or maybe not exactly double, but much faster. We will calculate delta time, the amount of milliseconds that passed between each call of request animation frame, and we will only allow the game to serve the next animation frame when a specific number of milliseconds has passed. We can calculate the delta time down here inside our custom animate function. First, I define last time outside the function, like this. Initially, I set it to 0. This variable will always hold a reference of the timestamp from the previous animation loop so that we can compare it with the current timestamp, and the difference between them will be delta time. Request animation frame has two special features. As we said, it will automatically try to adjust itself to the screen refresh rate, in most cases 60 frames per second. It will also automatically generate a timestamp for us that we can use, and it will pass that timestamp as an argument to the function it calls, in our case animate. Imagine it's passing that timestamp here, like this. Automatically it's auto-generated. All we have to do to use it is to assign it a variable name here. I will call it timestamp, spelled like this. Be mindful of lower and uppercase letters when defining your variable names. In JavaScript, it matters. Let's just console log this auto-generated timestamp variable that request animation frame is giving us, just to see what format it is in. You can see it gives us milliseconds since the first animate was called. 1 second is 1000 milliseconds, so here I can literally see that the game started 9, 10, 11, 12, 13 seconds ago. I delete this console log. We know we have access to the current timestamp, so let's use it to calculate delta time. It will be the difference between the timestamp from this animation loop and the timestamp from the previous animation loop. Delta time is the number of milliseconds it took our computer to serve the next animation frame. Once we used last time to calculate delta time, we assign it to the current timestamp. This way, the current timestamp can be used in the next animation loop as the old timestamp. For the very first animation loop, last time will be 0, but after that it will always hold the value of the timestamp from the previous animation frame, so that we can compare it with the value of timestamp from this currently running animation frame. And that difference between them is delta time. So let's console log delta time to see if it worked. My delta time is around 16.6 milliseconds. 1000 milliseconds divided by 60 is 16.6, so this checks out. I wonder how many of you got the same delta time and how many of you got a different number. If you have a high refresh screen, your delta time will be a much smaller number. If you have an old computer that is struggling to animate our game, your delta time might be much higher. If you have a second, write your delta time in the comments so we know if most people get the same or very different values than me. It will help me to better optimize my future courses. If I scroll up in the console to the very first timestamp, you can see that the first two values of delta time are none, not a number. It is because the very first timestamp is undefined, because only on the second loop this timestamp value gets auto-generated by request animation frame. The first loop is not triggered by request animation frame, it's triggered by this line. So in the beginning, when we say that delta time is undefined, -0 here, we get none, not a number. It automatically fixes itself as the loop runs, but these two initial not a number values could break your code that depends on delta time, unless you account for it with some kind of OR statement, for example. The easiest way to fix this is to pass 0 here as the timestamp for the first animation loop. From the second loop, the value will become the auto-generated timestamp, because after that, animate will be called by request animation frame. As you can see, we get numbers here, and there are no none values anymore. Perfect. I delete this console log. So let's use delta time to set frame rate of our game. We will need some helper variables. FPS, frames per second, will be, for example, 20. Timer will count over and over from 0 towards a specific value. When it reaches that value, it will trigger the next animation frame and it will reset back to 0. Interval will be that breakpoint value that, when reached, will reset timer. It will be 1000 milliseconds, 1 second divided by FPS. This will give us the amount of milliseconds needed to achieve this specific FPS. We will manage this frame handling logic down here inside render method. If timer is more than interval, do something. At the same time, keep increasing timer by the value of delta time over and over. So when timer accumulated enough delta time, enough milliseconds, that its value is more than interval, we will animate the next frame. We will also reset timer back to 0 so that it can count again for the future frame update. I will take all this code and I put it inside the if statement, like this. We are using delta time value on line 173. That value will be passed as an argument to render method up here. And inside animation loop, we are calculating delta time here, and we will pass it to render, like this. Okay, so something is happening. The reason everything is blinking is that we are deleting old paint all the time, but only redrawing our game when timer reaches interval. I cut this clear rectangle from here, so now we are not clearing old paint at all, and everything is animating at 20 frames per second, and everything is leaving trails. And I will clear old paint only when we are ready to redraw the next updated game frame here. So context, clear rectangle from coordinates 0, 0 to this.width, this.height to clear the entire game area. One optimization would be to draw our game on multiple canvas elements and only clear the portions of canvas that actually update it. That way we wouldn't have to redraw everything all the time. For now this will work fine. You should be able to see a slowdown in game animation speed because we are setting FPS here to 20. To make it even more obvious, maybe I only want to animate 5 frames per second. 30, 40, 50, 60. I'm setting FPS to 60 frames per second, but we are not actually animating our game at 60 FPS because every time I reset timer back to 0, there is some leftover delta time I am not accounting for. So even though I say 60, the actual FPS is a bit lower. I can go down and I can account for that leftover delta time, but maybe I want to keep this codebase lightweight. Maybe I don't want to make JavaScript do even more calculations over and over, so while keeping this in mind, I will know that I have to set FPS to a slightly higher value here to actually get something around 60 FPS. If I set this to 70, I think we get smooth enough movement and we are not making JavaScript calculate leftover delta time, which would slightly increase how performance demanding our game is. I just thought of this now, not sure which is a better solution. I will leave my code like this for now, but I guess the right solution here will be up to everyone's personal preference. Feel free to discuss this in the comments. I will consider your feedback in my future projects. Now that we know how to control animation speed of our game using delta time, the game will run at a similar speed on every machine, even for those of us who are using high refresh rate screens. I want to add eggs that can be pushed around, to include even more physics in our game. Those eggs will be hatching into creatures after a specific timer has passed, and player's job will be to protect the creatures that hatch. The eggs can be pushed around by enemies, but they won't be destroyed. The challenge for the player is when they hatch. Enemies will eat the hatchlings, so player's job in our game will be to position the eggs to protect them or to push enemies away from the path of the newly hatched creatures. The larva that comes from each egg will always try to crawl to safety and hide in the bushes inside the mushroom forest at the top. This will introduce a lot of player choice and player options into our game. While using physics, we implement it. I got an idea for this game mechanic while watching a nature documentary, where little baby turtles are hatching on the beach and trying to get to the sea for safety. In our game, we control the blue bull. Its job is to protect the hatchlings by pushing eggs, larvas and enemies around. This game is all about physics and positioning. I will have a custom class I call, for example, egg. Constructor will expect a reference to the main game object as usual to make sure egg class has access to many important properties held on the game object. X will be part of the game physics, so I need to make sure I define separate X and Y coordinates for collision circle center point and for the sprite sheet. Let's start with collision X property. It will be a random value between 0 and the width of the game area. Collision Y will be between 0 and game height, like this. Collision radius, for example, 40 pixels. This .image will be document.getElementById and the ID is egg. In index.html, I actually have to create that image element. As always, images can be downloaded in the resources section below. I hide it with CSS here. I'm keeping the same naming conventions across my objects. It's a good practice. So sprite width will be 110 pixels and sprite height is 135. Width and height will be set to these same values. In our game, every object has collision X and collision Y properties that represent the center point of collision area circle. Even player and obstacles have the properties named like this so that we can use reusable collision detection method to implement our physics to everything. Same goes for sprite X and sprite Y properties. Those represent the top left corner position from which the object's image will be drawn. Sprite X of egg image will be collision X plus half of the width of the egg image to center the image over collision circle horizontally. Sprite Y will be collision Y plus half of image height. We might have to adjust this a bit later because vertically we want the collision area to be at the base of the egg, not in the middle. We'll get to that soon. Draw method will expect context as an argument, as usual. We call drawImage, and this time we just need 3 arguments: the image we want to draw and X and Y coordinates where to draw it. If we were scaling, we would also include optional width and height arguments like this, but I'm giving you all the images in the same size we are drawing them in game, so it's actually not necessary. As with all game objects, we are not only drawing the image representing the object, we are also drawing collision circle if debug mode is active. Since we are keeping the same naming conventions for properties all over our code base, we are making our life easier. I can just copy this entire code block and use it here. So we are drawing X image, and if debug mode is on, we are drawing collision area. Yes, probably it's a good idea to put this code in a reusable method, since we are using the same code to draw collision circles for everything. I might do that later. For now, I want to create a method that will periodically add a new egg into our game. On the game class, we will have an array that will hold all currently active egg objects. I will also have another property called number of eggs, or max eggs describes it even better. We will only be adding new eggs to the game until the total is less or equal to max eggs value. Inside render method here, we will handle the logic to add eggs periodically. We already did it. We did periodic event in this code base where we used the delta time and triggered new game frame only when a certain interval value was reached. We will actually do the same thing here. We will need some helper variables for that. egg timer will go from 0 to egg interval value. Then it will add a new egg and it will reset so that it can count again. We are operating with delta time, so milliseconds. I want to add new eggs, let's say every 500 milliseconds. Down here I will check if egg timer is more than egg interval. We add a new egg by calling this method from line 220. Inside there, I just take the eggs array, I call built-in array push method, and I will push one new instance of our custom egg class in there. As usual, we know that the egg class expects game as an argument, so I pass it this keyword because we are inside that game object here. So if egg timer is more than egg interval, we call add egg. We will also reset egg timer back to 0 so that it can count again towards the next egg. Else we keep increasing egg timer by delta time, which we are already passing here to render method from before. I console log this.x to see if the objects are being added. Sorry, this will just create an endlessly growing array. I need to create additional condition here. Only add new eggs as long as the length of eggs array is less than max eggs. That's better. I inspect one of the egg objects. I need to make sure all the properties have values. If, for example, I have undefined as collision x coordinate, my eggs wouldn't be drawn on canvas because JavaScript wouldn't know where to draw them. I see values on everything. This looks great. Inside render method, I would also like to draw my eggs. I just copy this line and I adjust it. For each element in X array, we will call it egg and we will call draw method on it. Perfect. Now we are getting some visuals which will make it even easier for us to tweak the details and polish it. The first thing I notice is that all the eggs are added almost instantly, even though I said I want one egg every 500 milliseconds. If I increase egg interval to 1 second here, I can see that something is wrong with my code. I know the problem must be inside this code block, and it's because egg timer is more than egg interval, and only then add a new egg. We need to use this comparison operator here. Sorry about that typo, you probably noticed it already before. Now it works. We get one new egg added every 1 second, as long as we have less than 10 eggs. I can also see that the egg images are positioned outside the collision circles. I change this plus to minus here, and also here. Now that's better. I want to adjust the egg sprite sheet in relation to its collision circle. Plus 35 will move it up. Minus 35 will move it down. Minus 30, I want it to match the bottom of the image as closely as possible, but also I don't want the collision circle to be too tall because I want the player to be able to walk behind the egg without pushing it. To have this illusion that our game area is in 3D and that it has some depth, even though in reality it's just a flat surface. We will do more to enforce this in a moment. Now I want to create a margin to make sure the eggs appear certain minimum distance from the edges of the game area, so that we can get the player between the egg and the edge to push it anywhere we want. I want the margin to be, let's say, collision radius times 2. The initial X position of collision circle will be a random value starting from left, from that margin value we just defined, and game width minus that margin. Down here I set egg interval to 100 milliseconds and I want 50 eggs, just to get a better idea where they can possibly spawn in our game. We have that left margin I wanted, but I can see that the eggs are too far to the right edge. So here I increase that right margin like this. Yeah, I'm happy with this. The eggs are now always fully visible horizontally, with some extra space left and right between the edges of the game area. Vertically I will do something similar, but the random position needs to start below the top margin area we defined earlier. I don't want any eggs in front of this background artwork. The way math.random works, I just pushed the range from here to here. I also need to narrow the range down by reducing the span of random values we get, so game height minus top margin. Now X can appear from here to here. I will reduce the randomized value by margin to give it some space at the bottom, like this. Perfect. If you are a beginner, math.random can be unintuitive. It's actually very simple, it can just take some practice. So here I'm saying set collision Y property to a random value starting from top margin here, because we're going from the top, and the range of random values is game height minus that margin minus this other margin, so X can appear anywhere between here and here vertically. I set interval to 500 milliseconds and max X to be, for example, 10 for now. This means we will get an egg appear every half second until the total count is 10. This is a physics game, so we want the player to be able to push the eggs around, to move them out of the way of incoming enemies, or to position them strategically to give the larva that will hatch from it the best chance of survival. In this game, I choose that eggs will be indestructible. Enemies will just push the eggs out of the way if they collide, but the larva that hatches will be eaten if enemy catches it, so positioning and pushing the eggs around is very important. Let's give the eggs some physics. I give each egg an update method. Inside, we will create a temporary helper array called collision object. This will contain all objects in our game that eggs will interact with. We will check for collision between each egg and these objects, so we will need player here, this.game.player like this, and of course we need the solid obstacles in here. I want all these elements to be on the same level in collision object array. We have player object here, and we will spread obstacles array into collision object array using spread operator like this. Spread operator allows us to quickly expand elements in an array into another array. I will actually call this collision objects with an S. I will call for each on it, for each of these objects, so in this case for player and all individual obstacles we have here, I want to use this check collision method we defined on line 225. If you remember, it takes object A and object B as arguments, and it returns an array that gives us true or false for collision, distance between two collision circle center points, sum of their radii, and horizontal and vertical distance between the two center points. I copy this array, I paste it up here, and again we will use destructuring to quickly define these 5 variables using a single line of code. I need a variable name here, so I will call the first one collision. True or false, whether the egg collides with player or any obstacle. We did this before. I want these to be let variables, and they will be equal to this.game.checkCollision between this egg, because we are inside update method on egg class, and one of the objects in collisions objects array. So as the for each method runs, we are running check collision method between this egg and each element in this array, and we are getting 5 variables that tell us more details about position and collision of these two objects we are comparing. If collision is detected, we will actually use all these values to calculate how far and in which direction we want to push the egg. Horizontal direction of the push will be the ratio between dx, the horizontal distance between the two center points, and the distance, hypotenuse of that imaginary right triangle. Because dx is a side of that triangle and the distance is hypotenuse, the longest side, we are dividing small value by a larger value. Because of that, unit x will be something between -1 and +1. dx can be positive or negative. Unit y, vertical push direction, will be the ratio between dy and distance. Now we will use this to move the egg. We are inside a code block that will only run if egg is colliding with player or any of the obstacles, so when collision happens, we take collision x of the egg and we push it 1 pixel outside of the radius of the object it is colliding with, so collision X of the object, the center point, plus 1 extra pixel to move the egg outside of collision area. So this is how far, and the horizontal direction of that move will be defined by multiplying it by unit X, which, as we said, can be positive or negative. We also need to move the colliding egg vertically. Collision center point Y of the egg will be collision Y of the object it's colliding with, plus radius of egg, plus radius of the object, plus 1 extra pixel, so that in the next loop, collision is false, times vertical direction defined by unit Y. Notice that here we are detecting collision and I am moving collision X and collision Y of the egg based on the position of the obstacle. This is just my choice, and doing this will make the egg move and all these elements will be solid in that interaction. When interaction happens, egg will move, player and obstacles will remain solid. They will not be pushed by the egg. Down here, we call draw method on each egg. We also want to call this new update method we just wrote. Let's test it. We are pushing collision circle of this egg. I need to make sure that collision area and sprite stick together. The simplest way would be to take this code that positions sprite X and sprite Y in relation to collision X and collision Y, and I will call it inside update method. I can remove the values here, and now we can push the eggs using player, and they will also collide and slide around our mushrooms and plants, around the solid obstacles. The eggs don't interact with each other, this is just my choice. I want the eggs to overlap so that a skilled player can push multiple eggs, kind of herd them together and push all of them at the same time. This choice will also keep our code simpler because we are learning. We are drawing everything on a single canvas element, so the draw order of our game objects, what is drawn behind and what is up front, will depend on the order in which we call draw methods on each object from inside render method here. Right now I draw obstacles, so mushrooms and plants, then I draw eggs, so eggs are drawn on top of obstacles as you can see here, and then we draw the player. Player is drawn on top of everything else. If I take the eggs and draw them first, they will always be drawn behind the obstacles and behind the player. And here we can see that it doesn't really make visual sense. I want to create an illusion of depth, fake 3D or maybe 2.5D. Objects that are low should be up front. As we move up, objects drawn on that vertical baseline should be drawn behind. For example, this egg should be drawn in front of this plant, not behind it. We can't really achieve that if we draw all eggs, then all obstacles, and then the player. We need to adjust our code a little bit. I will have to put all these objects into a single array, and I will sort that array based on vertical coordinates. Let me show you what I mean. I create a new property on the main game class. I will call it GameObjects. At first, this will be an empty array. Inside render method, I will take GameObjects and I will use spread operator to expand the entire eggs array inside. I will also expand the entire obstacles array in here and I will add the player. Now we are holding all the game objects in a single array. This array will be recreated every time render method ticks. Good optimization tip here would be to only do this operation when vertical coordinate of any element changes or when we add or remove an egg. I will repurpose this code block and instead of calling for each method on X array, I will call it on this new GameObjects array. For each element in the array, I will assign it a temporary variable name, for example object. For each object in GameObjects array, call their associated draw and update methods. For this to work, it's important that all objects we add into GameObjects array on line 217 have draw and update methods defined on their classes. Otherwise the code would break because JavaScript wouldn't be able to find that method. So we are calling draw and update on all game objects, on all X, on all obstacles, and on the player. That means I can now delete these lines of code. Typo here, I spelled game objects with an S. Now we draw the first obstacle and then we get an error. We call the draw on the first obstacle, and when we try to call update on it, we get a type error that says object.update is not a function. I go to my obstacle class and you can see, as I said, we have draw method here, but there is no update method. We are asking JavaScript to call a method that doesn't exist on this object. I will create an update method here. Inside that method, we could, for example, animate sprite sheets of these plants and mushrooms every time the player collides with them or something. Maybe I will add some interactive obstacles later. For now, we will leave this method empty. Now it's working and we are calling draw and update on all X, all obstacles, and on the player. Alternatively, I could have also solved the lack of update method on obstacles by some kind of if-else statement down here. There are always multiple ways to do something. Feel free to discuss how you would approach this differently. Maybe we will get some better solutions in the comments that I might use in future classes. I appreciate when you give me feedback on my code and when you suggest improvements. Okay, so now we are calling draw and update as we cycle through game objects, which means X are drawn first, obstacles are on top of X, and player is drawn last on top of everything. If I change the order of these elements here, the player is drawn behind now, then X, and obstacles are on top of everything. So now we kind of understand how the layering works. It depends on the order in which we call draw method on each object. To draw our game objects in the order that makes visual sense, I can now sort game objects array based on each object's vertical position. I take game objects array and I call built-in array sort method. This method sorts the elements in an array and it returns the same array, now sorted. By default, if we call it without passing it any arguments, it will just convert array elements into strings and it will sort them based on their Unicode values. We don't really want that, so we will pass it an argument. This optional argument we can pass to array sort method is a compare function, a custom function that defines some logic. It defines some specific sort order we want. This special function will take two arguments, element A and element B. All elements in the array, in our case in game objects array, will be represented by this A and B and used in this logic we define here. I can do return like this and I want to sort the elements in ascending order based on the value of each object's collision Y property. So we are sorting based on the vertical center point of collision circle area. Alternatively, we could also sort by the bottom of sprite image, which would be sorting by the value of sprite Y plus sprite height. Sort method can be complicated to understand if you are a beginner. All you have to understand here is that I'm putting all my elements into game objects array. Then I'm calling built-in sort method on that array and I'm organizing these elements based on their vertical position. It doesn't work now because I'm creating an array, I'm drawing, and then I'm sorting. I need to sort the elements after I created the array, but before I draw them. So, like this. Perfect. Now this egg is drawn in front of the plant, but if I use the player to push it up, the egg's vertical position becomes less than the vertical position of the plant. Now the egg is drawn behind the plant. This is one simple way how you can draw elements in a 2D game in a way that makes more visual sense. It is a very powerful technique to add to your coding toolkit. Do you have any questions? Leave a comment. You don't have to do the following thing I will do now. I set egg interval to 20 milliseconds and max x will be 150. Just testing if there are any problems we need to solve. As I move through them, the physics seems very good. It's all working well. Having so many eggs for testing also gives me a pretty good idea where they might potentially spawn. They appear in the area we specified with large top margin and smaller margin from left, bottom and right. We got eggs. Nice job, coders. I set interval to 1000 milliseconds, 1 egg every second, and max eggs will be 20. Since we have this collision formula in place, if egg appears on top of obstacle or the player, it gets automatically pushed outside its collision radius. I remove this console log on line 237. We have our game world, we have randomized solid obstacles, we have mouse-controlled player character that can move in 8 directions, and we have eggs that spawn in specific interval. On top of that, everything collides and reacts to everything. We can make so many different games with this. Let's add enemies. I create a custom class I call, for example, enemy. As usual, constructor will take a game as an argument, and we convert that reference to a class property. We do that to get an easy access to all properties sitting on the main game class from inside enemy class through this.game reference. We need to keep the same naming conventions here, so collision radius 30 pixels, collision x, center point of collision circle will be the right edge of canvas, this.game.width. Collision y will be a random value between 0 and game height value coming from here. Speed x, horizontal speed, will be a random value between 0.5 and 3.5. You can download enemy image in the video description. At first, we will start with a static single frame. ID will be toad, source will be toad.png. I hide it with CSS because we want to draw it with JavaScript on canvas. This.image property will be getElementById, and the ID we gave it was toad. Sprite width, in this case 140 pixels, and sprite height is 260. I will also create width and height properties. And we will define sprite x and sprite y, positions of the sprite sheet image which will be positioned in relation to collision circle coordinates. Draw method will take context as an argument. Built-in draw image method, and because the image file I'm using is already the same resolution as the size I want to display it in the game, I only need to pass it 3 arguments: the image I want to draw and x and y, where to draw it. I will also copy collision circle visual that will appear only when debug mode property is set to true, only when debug mode is active. I just copy and paste it here, since that code is the same for all our objects. Update method. In there I want enemies to move to the left, in the minus direction on horizontal x-axis by speed x, a value we defined on line 179. So we are moving enemies to the left. If the right edge of the sprite sheet is hidden behind the left edge of canvas, we can set its x position back to game width so that it can walk left across the screen again. We will also randomize its vertical y position to get the enemies walking in different lanes. So I will have enemies that walk from right to left and then they reset and walk again. Alternatively, I could have also created new enemy objects over and over and destroy them, discard them when they move off screen. The code would be simple, but reusing objects by resetting their position rather than creating new ones and discarding them later is a good optimization technique. Always reuse your objects and reset their positions if you can, rather than creating new ones. Using the new keyword to create a new object is more expensive than resetting existing object. On the main game class, I create a custom method I call, for example, addEnemy. Up here, we will have an array that will hold all currently active enemy objects. Whenever addEnemy runs, it will push new enemy object into enemies array. Up on line 174, I can see that enemy class constructor expects game as an argument, so I pass it this keyword, because here we are inside this game class. Doing this, I'm just passing a reference that points to a space in memory where game object is stored. I'm not creating a copy of game object each time I create a new enemy. Init method will run just once to initialize our game and set everything up. Inside, we are already creating obstacles. We will also create enemies in here. For loop that will run, let's say 3 times, and each time it runs, it will call addEnemy method we just defined. I console log this.enemies and, as expected, it contains 3 enemy objects. I inspect one of them just to make sure nothing is undefined, which could be a problem. All is good here? I can delete the console log. It's a good idea to always check your objects and arrays with console logs as you build your project step by step to catch potential bugs and typos in time. To draw and update enemies, I just have to expand enemies array into game objects using the spread operator. We did that before. I see only collision hitboxes. I need to give some values to sprite X and sprite Y so that JavaScript knows where to draw the images. Position of the sprite will be moving as collision circles move, so I put that code inside update method. Let's first center it, then we offset it. Sprite X is collision X minus half of sprite width, like this. Sprite Y is collision Y minus half height. I want the collision circles to match the shadow on the ground below our floating enemies as closely as possible. We need to adjust image positions vertically. Minus 40. Minus 60. What about minus height? Plus 40. I can enable and disable debug mode to show and hide hitboxes by pressing letter D. We have enemies coming from right to left and then resetting. I want them to reset all the way behind the right edge so we don't see them just pop into existence. So we reset them to game.width plus width of enemy, and on top of that another game width times 0.5 to give each one a different random delay. Why is this here? I delete that. Just for testing, let's increase the speed. Resetting them at a random offset behind the right edge works well. Maybe that's a bit too fast. I need to restrict their vertical positions. Let's say start from the top margin. And from there, a random range between 0 and game height minus top margin. I copy this value to be used as the initial collision X position inside the constructor. And I take this new collision Y and I use it inside reset check in update method. This will not work because up here on line 176 I'm using this.width, but it's not defined until later here on line 183. The order here matters. I just take these 2 lines and I put them here. Now we have enemies walking from right to left in a correct corridor and resetting behind the right edge. This way we can reuse the same enemies over and over unless I decide we want to add some other features like allowing player to destroy enemies or something like that. We will see. Again, you don't have to do this part, I'm just testing our code. So I create 30 enemies. Having so many enemies gives me a better idea how they reset and I can spot any potential issues faster. Everything seems to be working well. This would be a very dangerous forest. Luckily for our hatchling creatures, the final game will not have swarms of enemies like this, unless you want to create a periodic wave of enemies like this, as one of the game mechanics the player has to prepare for and avoid. We can do so many things in terms of game design here. I'm just giving you the tools and techniques and showing you some of my ideas. Feel free to expand this game with your creative ideas when the course is finished. Let's go back to 3 enemies. Right now, the enemies are just flying through the forest without interacting with anything. First, I want them to react to solid obstacles and the player. We already have code that does that inside update method on egg class. I can literally use the same code block and put it inside update method on enemy class. This will make enemies treat obstacles and player as solid impassable objects, and they will slide around them. We are inside update method on enemy class, and we are passing enemy as object A and player and obstacles as object B, and here we are saying adjust position of A based on position of B. Player and obstacles will be solid and dominant in this interaction, and enemies will be pushed around them. This simple collision check-in will also create very basic artificial intelligence, as you can see enemies are walking from right to left across the game area, and they are automatically sliding and avoiding obstacles and the player. Because they avoid the player in this way, we can also use the player to push enemies around, same as we can push the eggs around. I adjust enemy speed. If I add X into collision objects array on enemy class, X will also become solid impassable obstacles for the enemies, and enemies will have to walk around them. It might be a good thing depending how you're designing your game, but the way I want my game to be, I actually want to remove the X from here. Instead, I go up to egg class, and inside update method I will add enemies to collision objects here. This will make the eggs object A passed the check collisions method, and enemies will be solid impassable object B. Enemies will push the X around if I do it this way. We implemented a lot of features, so I will leave the source code from this stage in the resources section below. You can download it and compare it with your files if you are coding along. Hope you're having fun! I go down here between egg and enemy classes, and I create a new class I call, for example, Larva. I want eggs to have a hidden timer, and after a certain time interval, each egg will hatch into a small larva. That larva will try to hide in the forest, and our job as a player is to protect it by pushing it closer to the safety zone or by pushing enemies away from it. Constructor on larva class will be a little bit different, because I want each larva to appear at the same position as the egg it hatched from. So we will pass it a reference to the main game object as usual, but also we pass it X and Y coordinates. Now I convert all these arguments into class properties. I need to name these X and Y coordinates collision X and collision Y. These variables will be involved in collision detection, so we need to name them the same as we did other objects in our physics game, so that we can use our reusable check collision method on these as well and involve these larva hatchlings in the game physics loop. We will also need collision radius here, let's say 30 pixels for now. You can download larva image in the video description. I added here with an ID of larva and source larva.png. It's a sprite sheet with 2 frames. On this row we have a bald larva, and this one has some fluff behind the neck, just to give it some visual variety. The fluff makes more sense if you know what these hatchlings turn into when they are adults. I bring the larva image into the project using getElementById, like this. Width and height of a single frame now. Sprite width is 150 pixels, sprite height is 150 pixels as well. If you are a beginner, I strongly suggest you follow my code exactly and use the same images I'm using. When the project is complete, it will be easier to make your own custom changes. Changing the code as you go while following this tutorial is not a good idea unless you are an experienced JavaScript developer. Making your own changes before the project is complete will make it harder to debug. We will also need sprite X and sprite Y, coordinates of the sprite sheet image. Each larva will need draw and update methods, as usual. Draw method will take context as an argument. Inside we call built-in draw image, and we pass it image we want to draw and X and Y coordinates where to draw it. I want each larva to be moving up towards the safety of the mushroom forest. This open area is full of enemies and it's very dangerous. Speed y, vertical speed, will be a random value between 1 and 2, for example. We defined sprite x and sprite y, properties that determine where the sprite sheet will be drawn, but because they will have to move every time Larva moves, I need to be updating them over and over from inside update method. Sprite x will be collision x minus half the width. Sprite y will be collision y minus half the height. I hide this image with CSS. We gave it an ID of Larva. So we have a class we can use as a blueprint to create a larva every time an egg hatches. Let's write egg hatching logic. We will need two helper variables. Hatch timer will go from 0 to hatch interval. It will count milliseconds, so let's say I want the egg to hatch after 5000 milliseconds, after 5 seconds. Inside update method, we handle collisions in this area, and down here we will handle hatching. If hatch timer we just defined is more than hatch interval, we do something. Else, we keep increasing hatch timer by delta time, counting and accumulating milliseconds. Delta time will be passed to update method up here on line 159. This update method will receive it here inside render. We calculated delta time value before inside animation loop. Delta time contains the number of milliseconds that happened between this animation frame and the previous animation frame. So hatch timer is accumulating this delta time, milliseconds between frames. If hatch timer is more than hatch interval, we will delete the egg and we will replace it with a larva. Up here I create a property called marked for deletion. Down here we set marked for deletion to true. I can be checking and removing these marked for deletion objects for every animation frame, but it might be a little bit more efficient to only restructure our arrays when something gets actually marked. So here we will call a custom method. I will call, for example, remove game objects. Down here on the main game class, I will define that method. So far, we are only marking X for deletion, so whenever this method runs, I will take the entire X array and I will call built-in array filter method on it. Array filter method will just create a copy of this array, but that new filtered array will only contain elements that pass the check provided in the callback function. The check in this case will be I only want X array to contain elements that have marked for deletion property set to false. If anything has marked for deletion set to true, it will be filtered out of the X array. This is so-called ES6 fat arrow function syntax. I'm saying take elements in X array one by one, assign each one a temporary variable name object, and on each of these egg objects, check if their marked for deletion property is false. Exclamation mark means false. If marked for deletion on this egg is true, that egg will be filtered out of this new array, and this new filtered array is assigned to the original X array and it overrides it. Am I over-explaining again? Let's console log this.game.x to see if eggs are being removed and added. Yes, this is working. Perfect. When we are in debug mode, I want the hatch timer to be visible as a number floating above each egg. Inside the draw method here, I call built-in fill text method. This method needs at least 3 arguments: text we want to draw and X and Y coordinates where to draw it. I need to change font size. Rather than changing font size every time draw method runs on each egg, I will set it up here on line 10 on the first page load. This is a powerful optimization technique. Font is a part of Canvas state, and frequent changes to Canvas state can affect performance. Define Canvas properties such as fill style, line width, stroke style, and font in a code block that runs as little as possible. Ideally, don't do this in a method that runs 60 times per second on multiple objects at the same time, although in some cases it might be unavoidable. All I'm saying here, if you can, set canvas properties on the first page load like this. All this code will run only once. I set canvas font to 40 pixels Helvetica. I could have also defined canvas font here in this draw method, but as I said, that line of code would run 60 times per second on each active egg. That's a lot of operations that can be easily avoided by doing what I just said. Hatch timer is this ridiculous number with so many digits after the decimal point. Let's clean this up. I create a helper variable called display timer. In here, we will format that number a bit before we draw it. I can, for example, take hatch timer and call built-in toFixed method. JavaScript toFixed method converts a number to a string and it rounds the string to a specified number of decimals. I actually want 0 decimals. I just want to see the milliseconds. I use that display timer variable here to actually draw it. I can adjust vertical position of the text, maybe by collision radius like this. Up here, I will set text align to center. This will align the timers and eggs horizontally. Nice. I want to push the timers even further up above the eggs. Maybe even more? Let's go with 2.5. Instead of milliseconds, I just want to see the seconds, so I close hatch timer in brackets and multiply it times 0.001. Now this is more readable. We can see number of seconds above each egg. Let's make each egg hatch after 3 seconds. Nice. When the egg hatches, it gets removed by the filter method. On the main game class, I create a property called hatchlings, and at first I set it to an empty array. Whenever an egg hatches, we will push new larva into this array. Up here on line 190, I can see that larva expects game and x and y coordinates. So when an egg hatches, I take this.game.hatchlings array and I push new larva inside. I pass it this.game and I pass it x and y coordinates of this egg that it hatched from. I remove this console log. Inside render method, I use spread operator to expand hatchlings into game objects array so that they can be sorted, drawn, and updated. Perfect. We are making progress. Now that we can see what our hatchlings look like, we can go up to Larva class and clean this up. First, we will check if the larva moved to safety. They are safe as soon as they reach this mushroom and bushes area, where they can hide. So if collision y is less than this.game.top margin, if larva moved past this point, we can set marked for deletion on it to true. We will delete that larva, because we don't want to draw it anymore, and we will call remove game objects. On line 350, inside remove game objects method, I do the same thing we did for eggs. Filter the hatchlings array, and if any larva object in this array has marked for deletion property set to true, filter it out. Just to check, I will console log game objects every time we remove an egg or a larva. I get an error, and it's because this needs to be this.game.removeGameObjects, because that method sits on our main game class. I want to draw collision circles on hatchlings. I copy this code block from enemy class. And I just paste it here. Because our classes have the same naming conventions on their properties, it's easy to reuse code like this. Right now, we are drawing the entire sprite sheet for each larva. I want to crop out just a single frame from coordinates 0, 0 to this.sprite width and this.sprite height. and we want to draw that cropped out image at position sprite X, sprite Y, and we need to give it width and height, like this, 9 arguments. I want to position a Larva sprite sheet image in relation to its collision circle. I try -50. Yes, that will work. I want the collision circle to align with the bottom of its body. I think that will make the most visual sense when interacting with game environments and characters. I remove this console log on line 362. Larva sprite sheet has 2 frames, but we are drawing just the top one. Let's randomize that. Frame Y will be a random value between 0 and 2, and since there is no row 1.5, for example, we need integers, whole numbers without decimal points. So I wrap this in method floor. This line of code will give us either 0 or 1, because method floor will round the value down to the nearest lower integer. Frame X will be always 0 until later in the class where I give you advanced sprite sheet for animation. We will use frame X times sprite width here as source X argument passed to draw image method, and we also need to define source Y. Source X and source Y coordinates combined will determine which area of the sprite sheet we are cropping from. Source Y will be frame Y times sprite height. Nice. Since frame Y is randomized to be either 0 or 1, some hatch links use sprite image from row 0, and some use the other one from row 1. Collision between hatch links and game objects will be handled here. I go up here inside update method on egg class, and I copy this code block. We will make some changes to it, but most of it will be the same, so we might as well copy it, so we don't have to write all of that again. I paste it down here inside update method on Larva class. I will remove enemies from collision objects because enemies will have a different type of interaction. So Larva will automatically avoid player and obstacles, and we can also use the player to push Larva around. Like this, which will be an important game mechanic. Collision with enemies will be handled down here. I take enemies array and I call for each on it. For each enemy object, I will call them enemy, for example. For each one of them, call this callback function. Basically, I want to say if this larva and this enemy we are currently cycling over with this for each method collide. One way to easily check if 2 game objects collide is to use our custom check collision method again. I want to check collision between this larva, we are inside Larva class, and each individual enemy, as this for each method runs. We know that our custom check collision method returns an array of values. It gives us collision, distance, sum of radii, dx and dy. Here I only want the first argument, collision, which will be true or false depending on whether or not this larva and this enemy collide. Check collision returns an array, and I want collision status, true or false. I want the first element in the array, so index 0, like this. So here we are using destructuring to extract all 5 individual variables from check collision method. Here I am directly accessing just the first value with index 0 because I don't need the other ones. The reason I don't need these other values when larva and enemy collide is because there will be no pushing around and no physics. The larva will just get eaten, so I set marked for deletion on this larva object to true. I will also call remove game objects to filter that larva out of the hatchlings array. I will also keep track of how many hatchlings we lost in this custom variable. This.game.lostHatchlings will be increased by 1. And here, where we check if larva moved to safety of the mushroom forest, we increase score by 1. So if we protect larva by positioning X pushing enemies away, or by pushing larva towards the forest. If larva successfully hides in the bushes, we get 1 score point. If larva gets eaten, lost hatchlings variable will increase by 1. Down here on our main game class, we create these properties. Score will be initially set to 0, and lost hatchlings also initially set to 0. I can use console logs or something like that to check if the code we just wrote works, but we need that text displayed to the player anyway, so down here we will draw game status text. Again, we will use built-in Canvas fill text method, which expects the text we want to draw and x and y coordinates where to draw it. I want to draw the word score at coordinates 25 horizontally and 50 vertically. Problem we have right now is that I want this text to be left aligned, and if you remember the text above X, the timer is center aligned. I will have to isolate this fill text call by wrapping it between save and restore built-in Canvas methods. Then I can set text align to left and I call restore. Save and restore methods work together, and we use them when we want to apply specific settings only to a certain draw call on Canvas, without affecting the rest of our project. I save Canvas state, I set text align to left, which will affect only this fill text call where we draw score, and then restore method will reset all Canvas settings to what they were when save was called. In this case, it will only revert text align back from left to center. I hope that makes sense. This is a very useful technique, especially if you want to scale and rotate your Canvas drawings. I do that in some other classes, for example in my Creative Coding Fractal class, if you want to know more about it. Now, score is left aligned and timers above eggs are center aligned. Perfect. I adjusted the text to draw. I want to say score colon space in quotes plus this.score variable to make it dynamic. Now, as hatchlings move to safety and hide in the forest, we can see our score increases. In debug mode, I also want to be able to see lost hatchlings, so if this.game.debug is true, I copy this line of code, text will say lost plus this.losthatchlings variable. Actually, we are inside game class here, so I need to say just this.debug. Yes, I change vertical coordinate here, and now, while in debug mode, we are also keeping track of how many hatchlings were eaten, how many hatchlings collided with enemies. Sometimes the larva hatches quickly and is eaten too fast, or sometimes larva disappears very close to the top edge while enemy is nearby, so it might not be 100% clear if it managed to get to the safety or if it was eaten. I would like to add an additional visual effect that will help us to make our game clear and easy to read. I want to add 2 types of particle effects. When the larva hides in the bushes, it will interrupt a swarm of fireflies that were sitting on the branches, and they will fly up in the air. When player sees those fireflies, they know that larva is safe. If larva gets eaten, I will try to come up with a different, very distinct particle motion, so if there are many game objects in the same area, we can still tell what's going on by seeing what type of particles are flying from there. I will also use this opportunity to talk about subclassing in JavaScript. We will have a parent particle class that will contain all properties and methods shared between all particle types. This is a so-called parent class, also called a superclass. Class Firefly extends this particle class. This is a child class, also called a subclass. We will also have a class I call Spark that extends particle class, like this. We have 1 parent class and 2 child classes. Child classes will automatically inherit properties and methods from the parent class, which will save us some code repetition. Let's write the code and talk about it a bit more as we go along. The parent particle class constructor will expect game, x and y position, because fireflies and sparks will always fly out from the position where the larva disappeared, And let's add one more, for example color here. Maybe I want one particle type to be gold and another one blue, depending on where in our code base was that particle created. I will show you what I mean. I convert all these arguments into class properties as usual. I'm saying take color that was passed as an argument here and save it as color property on this instance of particle class. You know how this works by now. Radius will be a random value between 5 and 15, but I wrap it in math.floor to only allow integers, so no decimal points. If we are creating many particles, you will notice a big difference in performance when we are using randomized values like this, compared to setting the initial radius to a fixed value of, let's say, 10 pixels for all particles. Randomizing object values when creating many objects is very performance expensive. You can improve your game's performance by trying to avoid math.random as much as possible if you know you will be creating many copies of that particular object. I know we will be creating many particles. We only have one player object, so there it doesn't really matter, it gets created once, but over the course of our game we will probably create thousands of particles. One way to avoid this would be a technique called object pooling. You create a pool of particle objects and only draw them and use them when needed. When it comes to performance, that would be much better than constantly creating new ones and deleting them. Speed x will be a random value between -3 and +3. This means some particles will move to the right in the positive direction on the horizontal x-axis, some particles will move to the left if their speed x is a negative value. For vertical speed, it will be a random value between 0.5 and 2.5 pixels per animation frame. I want to use a little bit of trigonometry to make the particles rotate, float and swirl around, so we will need an angle value. Initially I set it to 0. VA, velocity of angle, will determine how fast is that angle value increasing. I will show you exactly how to use this in a minute, don't worry. VA will be a random value between these two very small numbers. We will delete particles that moved off screen. Initially, I set their marked for deletion to false. Draw method will be on the parent particle class as well, so it will be shared for all fireflies and all sparks. I want to make sure that changes to canvas state we make here remain isolated to this particular particle, so I wrap the drawing code between save and restore built-in canvas methods. We set fill style to this.color from line 303. I call begin path to start a new shape. Built-in arc method will take horizontal center point, vertical center point, radius, start angle, and end angle. I want to draw a full circle, so from 0 to math.pi times 2. Math.pi times 2 is a value in radians, and it converts to 360 degrees. It's a full circle. We have to use values in radians here when passing them to arc method. Then I call fill to fill the path with color, and I will also stroke it. Because in our game everything has this vector art style with black outlines, I want the particles to match it. Class Firefly will contain only update method. Same for Spark. Later when we call draw method on Firefly class, since this class extends particle, JavaScript will automatically look for draw method and for constructor on the parent particle class. Doing this will save us code repetition. I don't have to define constructor and draw method twice if it's shared for Fireflies and for Sparks. We can only define it once on the parent class and JavaScript will find it. It will be inherited. Fireflies will have unique motion. I'm thinking floating up and swaying left and right, which is very easy to implement. First, we will be increasing angle by VA, angle velocity, for each animation frame. Then, we will increase collision x by speed x. Since speed x can be positive or negative, they can start going left or right randomly. Collision y will be minus equals speed y, because I want them to float up in the negative direction on the vertical y-axis. If Firefly moves all the way up and it's hidden above the top edge of game area, so if its collision y center point is less than 0 minus its radius, we set its marked for deletion to true and we will call removeGameObjects. On the main game class, I create a property called particles. It will be an array, and it will hold all currently active particle objects. I expand particles into game objects so that they can be sorted, drawn, and updated. Inside removeGameObjects, I add one more line of code to filter out particle objects with marked for deletion property set to true, like this. Let's try to create some particles. I will create them up here on Larva class. In this code block that runs when Larva hides in the forest, we get a score point, and I want a swarm of fireflies to fly out of the bushes. I take this.game.particles array and I push one new firefly inside. I remember that particle class constructor expects 4 arguments, a reference to the main game object as usual, so I just pass it this.game along from Larva constructor. Initial start in x and y of this particle will be the last x and y position of the larva we just deleted, and color will be red, for example, just to test it. Nice, we have red particles with white outlines. If I want more than one, I just create a for loop. Let's say I want 3 fireflies each time. I will change color to yellow. Let's see what that looks like. Nice. Particles need black stroke. I can set it inside the draw method on each particle, but in this project I'm not using stroke on many other things. I can just set stroke to black globally here on line 9. This will be more performance efficient. It will also give black strokes for collision circles while we are in debug mode, but I don't really think it's a problem. It might look even better like this. Fireflies have a very basic left and right upwards motion. We are not using that angle, we are increasing endlessly on line 327. Easy way to make something cycle back and forth is to pass ever increasing angle value to math.sine or math.cosine method. When your code is like this, VA, by how much angle increases for each animation frame will determine the speed of swaying, and this.speedx will determine the curve, the radius, how far left and right the motion goes. Perfect. Whenever Larva successfully hides in the forest, we get a score point, and we get confirmation by seeing this firefly effect. I want sparks to look different, so that in case that larva and enemy are obscured behind obstacles or something, you can still see that the larva was eaten based on the particle effect that happens there. In here, I will define a different update method with different code inside, so Firefly and Spark are both child classes of the parent particle class. They both inherit code in particle class constructor, and they both share its draw method, but each one will have a unique update method where we handle motion. I will increase angle by angle velocity, VA again, but I will slow it down, so times 0.5. Horizontal position will be minus equals math.cosine. We pass it this ever-increasing angle value to map it along a cosine curve, and we define the radius of that curve using speed x. Collision y will be minus equals math.sine, and I pass it the same angle value, and radius of the curve is speed y value. We go back up to Larva class, and here, if Larva collides with an enemy, we delete it, and I want to create a swirl of particles. I will just copy this code block we used to create 3 fireflies, and I copy it here. In this case, we want to create 3 sparks, and color will be blue. How do I do this? Now I need to push the larva in front of enemy to see what happens when it gets eaten. Nice, we get blue sparks and some kind of circular motion. Just for testing purposes, I will create sparks even when larva hides in safety so that the animation happens automatically more often without me having to chase them around. I need to see it so that I can adjust the movement. What can we do with this? I love particles, you can do so many different movement patterns so easily. For example, let's make them shrink. If you try to draw a circle using arc method that has radius less than 0, you will get an error, so we have to be very careful here. I say if radius is more than 0.1, keep reducing radius by a small value. That value needs to be less than 0.1 to make sure we can't get below 0. Also, if you remember, we are only removing old particles if they move past the top edge of canvas. And these swirling particles never do, so I need another condition here. If radius is less than 0.2, just to be safe, set its marked for deletion to true and call removeGameObjects method. Nice, this looks interesting. I want them to kinda explode to both sides. I haven't mentioned it before because it's not necessary to fully understand trigonometry for this course. Sine and cosine work together to map a circular path if we give them the same values. Look what happens if I swap sine and cosine. All you have to understand about sine and cosine for animation purposes is that if you pass them ever-increasing angle value, and when you attach these values to vertical and horizontal positions of your object, you will get a circular movement. The best way to get some clarity is to play with the values, try to break it, adjust the code, and see what happens. Don't worry about fully understanding trigonometry today. It can be complicated for beginners, and it takes a while to master. I'm drawing 30 particles here to give me a better idea about the motion that happens, and if we get any edge cases appear that needs to be accounted for. You don't have to do this. I recommend using only 3 particles each time for performance reasons. You can see the sparks are kind of swirly explosions. I like it. The motion is very different from fireflies. I give them yellow color here, and I will go back to using fireflies. Let's see what that looks like. So we know how to extend JavaScript class to avoid code repetition. We created a parent particle class and 2 child classes, Firefly, that indicates to the player that Larva managed to hide in the forest by disturbing a swarm of glowing bugs that float away upwards. And when Larva is eaten by an enemy, it will turn into a swirl of magical sparks that slowly shrink and disappear. I will go back to 3 fireflies here, and down here let's create 3 sparks. Or maybe 5, because they shrink so fast and often they are obscured by obstacles and other game objects. We want to make sure they get noticed when they appear. I would also like to allow the player to move the eggs to the forest to get score point immediately. I want eggs to instantly hatch when we push them high enough into the safe area. That egg will automatically turn into larva and into fireflies instantly, and we will get a score point. I can do that up here on line 179, where we check if hatch timer is more than hatch interval to turn egg into a larva. I want this code block to also run if the egg was pushed to safety zone, if vertical position, collision y, is less than this.game.topMargin. To test it, maybe I should increase hatch interval, otherwise these eggs hatch too fast. I see an egg here, no here, and I push it. Leave me alone. Okay, now here we go. It hatched instantly, while hatch timer was only 7 seconds. I try again with this egg, and yes, this works, and we are also getting score points for that. Perfect. I prepared many different enemies for you. You know how we have a single image file with multiple obstacle types? I also prepared many different toad skins for you that will play the role of enemies in our game. I had a lot of fun making different variations and imagining what types of special abilities and special moves they could have. Let's say for performance reasons we want to use just a set of static images for enemies. We will also animate these later if that's what you want. In the final version of the game, everything will be animated. All the project images can be downloaded from the resources section below as usual. I'm giving you all this premium game art for free. This course is designed to give you the maximum value possible. Feel free to use these art assets for your own projects if you want. So I bring this sprite sheet with 4 frames, 4 enemy types into the project. ID is toads and source is toads.png. I hide it with CSS as usual. In script.js, inside enemy class constructor, we create 2 helper variables that will help us navigate around the sprite sheet and crop out 1 random frame for each enemy object. Frame X will navigate around the sprite sheet horizontally, and it will be initially set to 0. Frame Y will navigate vertically, and it will also start at 0. I will need the longest version of drawImage method to define what image I want to draw, source X, source Y, source width, and source height to specify which rectangular area I want to crop out from the source image, and destination X, destination Y, destination width, and destination height to define where we put that cropped out piece of image on destination canvas. 9 arguments in total. Image to draw, cropping area, and where to put that cropped image. Let's start by cropping just the top left frame, so we crop from coordinates 0, 0 to coordinates sprite width, sprite height. This sprite sheet has only 1 column, so frame X will stay at 0. I want to crop out 1 vertical frame at random, so source Y of the cropping area will be sprite height, pushing the start of the cropping area here, giving us this frame. To actually see it, I need to use the new image with an ID of toads. So to be clear, 0 times sprite height will give us this frame. 2 times sprite height will crop out this frame. The value we pass as source Y to drawImage method will determine where do we start cropping from vertically. Instead of this hard-coded value, we can use frame Y. Now, when I give frame Y a different value, it gives us different enemy types. I want each enemy object to be randomly assigned one of these images when it's created. So we have 4 rows, math.random times 4, and if I wrap it in math.floor, frame Y will be either 0, or 1, or 2, or 3. I will also replace source X with this.frameX times sprite width. This will become relevant a bit later when I give you the next sprite sheet. For now, let's leave frame X at 0. It would also be nice to randomly reassign the image every time enemy moves off screen and resets, so we make use of all available images. I just randomize frame Y here, like this, to achieve that. To quickly test this, I increase enemy speed to a random value between 5 and 8 pixels per animation frame. Enemies are resetting and images are randomly changing every time they reset. Perfect. Let's go back to a lower speed. I set max X to 5. Since we are using static images for enemies at this stage, drawing them is very cheap in terms of performance. Maybe I could increase the number of enemies to 5 as well. This is starting to look really good. I want to display a winning and losing message. On the main game class, I create a property I call, for example, winning score. For testing purposes, I set it to 5. We will draw winning and losing message down here. If score is more or equal to winning score, I will wrap it in save and restore to restrict some drawing settings we will use now only to that win or lose message. I want to draw a semi-transparent layer to indicate the game is over and also to make the message more contrasting against the background. So I set fill style to black, 000 and 0.5 opacity. Then we will draw that black semi-transparent rectangle over the entire canvas from coordinates 0, 0 to the width and height of the game area. Let's run this code to test it. When we reach score 3, we should get that semi-transparent layer. Yes. After that rectangle is drawn, I will change fill style to white to make sure the text is contrasting against the dark background. I set text align to center. We will have a main message in large letters and a secondary message in smaller font. I will just define them like this as let variables, and the values these messages get will depend on how well we played. In any case, this message will only display after score is more or equal to winning score. But let's say if we played well and we lost only 5 or less hatchlings, we will get a winning message. If we lost more than 5, we will get a losing message. The goal of the game is pushing eggs, hatchlings and enemies around to make sure we protect as many as possible. So if we play well, message 1 will say, let's play with words a bit. You can write anything you want as a winning and losing message here. So if we win, the main message in large letters across the screen will say bullseye and some exclamation marks. The secondary smaller message will say, you bullied the bullies. If we lose, the main message will say bollocks. Secondary smaller message will say you lost. Plus, we will display dynamic variable value to show how many hatchlings got eaten. Plus, hatchlings, comma, don't be a pushover. This is a physics game about pushing things around. We need to learn to push better. I'm using a good old string concatenation to construct this dynamic message. Even better would be to use template literals here, if you are familiar with modern JavaScript syntax. Now we actually want to draw these messages. The large message one will be, for example, 130 pixels Helvetica. Fill text method will take the text we want to draw, message 1, and X and Y coordinates will be the middle of canvas horizontally and vertically, like this. The second message will be smaller, 40 pixels Helvetica. Fill text will draw message 2 in the middle of canvas as well. One more fill text call that will say final score space plus we will display the final score value there plus full stop to end the sentence. And another sentence will say press R to butt heads again. I want to show you how to implement a very simple restart functionality whenever we press letter R on the keyboard. I will also draw it in the middle of canvas vertically and horizontally. Now I have to space those messages out so they are not drawn on top of each other. I adjust the vertical position of message 1 by minus 20 pixels, moving it up in the negative direction on the vertical y-axis. Message 2 will be plus 30, pushing it down. Message 3 will be plus 80. Let's see what that looks like. Yes, this spacing is much better. We have our winning message. When score is more than winning score, we set game over to true. On the main game object, I define game over property and initially I set it to false. The simplest thing we could do here is to freeze animation when game over happens. I can do it, for example, down here. I say only serve the next animation frame if game over is false. When game over becomes true, the game will freeze. I set winning score to 1 just for testing. And it will display winning or losing message, and it will freeze like this. I go down to line 519 and I delete this bit. I would like the game to keep running, but we will make new eggs stop appearing and I will prevent enemies from resetting so they just flow off screen and stay there. So, whenever game over happens, the objects that are already in the game area will just finish the action they are doing, but new objects will no longer appear. The game will just finish playing out behind the winning or losing message, but new eggs will no longer appear and enemies will stop coming. Player will still be interactive and we can still move it around in the empty game world. How do we implement this? It's simple. First of all, let's say winning or losing message appears and we still have some eggs hatching. On Larva class, we will make sure that we get score points only if game over is false. When game over happens, hatchlings will still appear from the remaining eggs, but whatever happens will no longer affect our score points. On the enemy class, I only want the enemies to reset if game over is false, like this. When game over happens, enemies will finish their movement across the game area, but they will no longer reset to the right, so new enemies will stop coming. Down here, we only want to add new eggs into the game if game over is false. When winning or losing message appears, the existing eggs will still finish hatching, but new eggs will stop appearing. Let's test it. I have a winning message. I have some leftover eggs, but these hatchlings no longer increase our score. We have some remaining enemies, but they just slowly move off screen and don't come back again. Player remains interactive and we can still move it around. Perfect. I want to test the losing message. Rather than intentionally pushing hatchlings in front of enemies to get eaten, I will just manually set lost hatchlings to 10 here on line 380. Yes, we get our losing message. This is great. I set lost hatchlings back to 0. Adding a custom font is easy. You can choose any font you want. I will go to Google Fonts. They have thousands of fonts available there. I want to use this comic book inspired font called Bangers. I click here to select the font and I click up here, which will generate some code I can use to include this font in my project. I copy these 3 link tags and I paste them up here in the head tag in my index.html file. Ideally before my custom style sheet, so the font is available from there. Then I copy this CSS rule. I use it here. In the case of this project, I can just apply that font family to all elements. You might want to be more specific and only apply it to the canvas element, for example. Now, the font is available in our project, so up here on line 10, I set canvas font to 40 pixels Bangers. This will affect the text that displays score and timers above hatching eggs. We also want to set Bangers here and here if we want to use it for game over messages. Let's quickly win the game. Yes, this looks better, doesn't it? Because we use save and restore here, everything I do in this area will remain restricted to game over messages. Canvas shadows are performance expensive and some browsers don't deal with it well, but if I limit them to this piece of text, we will be okay. Let's try it. We need to define horizontal distance between shape and the shadow. It can be a positive or a negative value, depending on if you want the shadow to be to the left or to the right. Shadow offset Y can also be positive or negative. It will determine vertical position of the shadow in relation to its parent shape. Shadow color will be black. We can also define shadow blur if we want. That one is optional, so I will leave it on default 0, which means no blur. Keep in mind that canvas shadows will only be drawn if shadow color is set to a non-transparent value and if at least one of the properties, shadow blur, shadow offset X or shadow offset Y is set to a non-zero value. Shadows give the text a nice highlight and make it stand out from the background a bit more. I set lost hatchlings to 10 again just to see the losing message, what it looks like with new font and shadows. Nice, this looks great. I set lost hatchlings back to 0. We have this message here that says press R to butt heads again, which means press R to restart the game. What I'm about to show you is the simplest way you can implement restart game functionality. On the player class, I create a custom method I call, for example, restart. Inside, I want to set player properties to what they are when a new game starts. Let's have a quick look what we have here. I want the player to move to the initial position. We will reset collision X and collision Y. We will also make sure that sprite image moves along with the collision circle, so I will need these 2 lines of code. So player restart method will move player collision area and player sprite sheet back to its starting position. We go down here to the main game class, and here inside key down event listener, I say if key that was pressed is R, call restart method on game class. Like this. I define that method down here, and in here we will set all properties to their initial state. This will be different from project to project. We just wrote this code base, so we are familiar with it and we understand what needs to be changed to restart the game back to its initial state. First, we will call restart method we just defined on the player class. Let's test it. I move the player, and when I press letter R on the keyboard, player will move back to its starting position. So far so good. We could use a similar technique to give the player an ability to rewind time, for example, where we just set state and position on X, enemies and hatchlings to what it was, let's say 5 seconds ago. That might give us some interesting gameplay. Anyway, we want to restart the game, so up here in the constructor I check what needs to change. I know I will have to reset the contents of my arrays. I take obstacles, X, enemies, hatchlings and particles, and I set all these back to empty arrays, like this. I test it. Okay, so when I press R, now this happens. I need to run init method again to recreate enemies and obstacles since we deleted them. Yes, now when I restart, obstacles get regenerated at random positions, and we also generate new enemies. I can see I also need to reset the current mouse position. I take this.mouse and I set it to these starting values actually, so I can just copy this. I also reset the score back to 0 and also lost hatchlings. I also need to set game over to false to make sure X keep appearing and enemies keep resetting. Let's test it. I play. I win the game, I press R to reset, I play, I win, I reset, I play, I win. Seems to be working alright. I set winning score to 30. Okay, I spent some time testing the gameplay and there are a couple more things we can adjust. As you know, we can enable and disable debug mode by pressing letter D. I'm here on our custom Larva class. I would like our Larva hatchlings to interact with X. Inside update method on Larva class, I use spread operator to expand X into collisions objects array. Doing this will make the X solid impassable obstacles and hatchlings will have to crawl around them. This will make the game a bit more difficult and player will have to get more involved to get the X out of the way to make sure the hatchlings reach safe area as fast as possible. Sometimes hatchlings can even get stuck between multiple X and obstacles, and if we don't free them in time, they will get eaten by enemies. Alternatively, I can remove X from here. I go up to the egg class, and inside update method on egg class, I will expand hatchlings into collision objects array. This, on the other hand, will make a game easier because not only will the hatchlings be able to push the X out of the way, they will also sometimes push the X in front of them closer to the safety zone. You can choose what you want to do here yourself, depending on if you want your game to be easy or more challenging. At this point, you know this codebase well enough, so if you want, you can take some freedom and adjust the gameplay however you want. I also want the collision circles on hatchlings to better match the sprite sheet. -40 here will work well, I think, to better align the bottom of collision circles with the bottom of bodies of the hatchlings. I want these collision areas to match the artwork as closely as possible. We are in debug mode now, but keep in mind that the game is meant to be played with collision circles hidden when debug mode is switched off. You can use the same technique to better align collision circles on enemies with the little shadow on the ground below each enemy. I will do that in a minute because the next lesson we will focus on adding new enemy types. I will also give you all the character sprite sheets and we will add a lot of animations to this project. I had so much fun designing these creatures and making them move. I hope you like it. I noticed one small edge case bug. When we get game over message and leftover enemies eat some leftover hatchlings, lost hatchlings variable still increases. We need to make sure that lost hatchlings value stays the same after game over message is displayed, so I will only run this code block if game over is false. This will also make the hatchlings invulnerable under the game over screen. If you don't want that, you can apply this if statement only to one line of code that increases lost hatchlings. If game over is false, lost hatchlings ++. In the extended version, we will add more features. We will animate the player, hatchlings and enemies. I will give you static and animated sprite sheets for all these characters. You will also get the full source code, but not only the final source code, but multiple stages as we progress with the project from the base game to the complete fully animated version. If you followed along and watched this far, you should be really proud of yourself. You can let me know by saying I did it in the comment section below. I'm looking forward to see what projects you come up with when you combine your knowledge and your creativity. I hope you got maximum value today. Time is the most valuable resource we have. Thank you for spending your time with me. I'll see you soon.